workshops that we have conducted. We are starting from the first workshop. This is a digital diabetes workshop which is to be chaired by Dr. Alok Modi. So I invite Alok to come here. He is a tall man, tall in height and tall in stature and tall in knowledge and tall in approach. So we usually get afraid to stand near him, but you'll see his approach to artificial intelligence, digital diabetes, and the way we are moving to. Diabetes is no more glimepiride and metformin. Diabetes is no more walk and food. They will be there as old classic Bollywood songs. But now we are moving towards the high-tech era where a patient's hypoglycemia will come as an alarm to your smartphone, and you have to use CGM, you have to use the pumps, use the devices to upgrade your practice. Those who cannot adapt to that will disappear, and those who adapt will grow, like Alok growing, like Amit growing, like Devasis growing, they'll be growing. So this is the time. There are no more debates on whether digital diabetes, whether the technology is fit for Indians or not. Last RSSDI we had the theme of technology in diabetes, but this time it's established. It's an established way. My suggestion is be a part of it. Have point of care testings. Get into digital diabetes and get patients' confidence and a smart way of managing things. That's why we designed this workshop. I welcome all the attendees. The workshop chair is Alok. I'll hand him over. And we have other faculties. Dr. Amit De, he'll be speaking after him. Dr. Debasis Das, Amit is from Calcutta. We have series of the, I'll formally introduce them and I'll ask the moderators to take over. So Amit is from Calcutta, Alok is from Mumbai, Devashish is again from Mumbai, and we have Dr. Shoyangsit Mangaraj from Bhubaneswar. He is at IMS and SOM Hospital. Shortly he is joining. For this session, we have two giants, young diabetologists who are futuristic as moderators. Professor Prabhat Kumar Thatoi, HOD Medicine, from Dharanidhar Medical College, Keonjhar, and Dr. Satyen Kar. We tell Satyen Kar, he is actually Satyanarayan Kar. Popularly people call him Dr. Satyen. He is from Rourkela with a dedicated diabetes practice for last 3-4 decades. So I invite both the moderators to be on stage. And we have rapporteur Dr. Dheeraj Panda. Yeah, please be here. You be here. You be here. No issue. Yeah. Get one more chair for the rapporteur. Or rapporteur can do his job from. Yeah, there are different types of reporting. One is reporting from behind. So Dheeraj prefers to be here. So Dr. Dheeraj is a consultant diabetologist, and we meet more often on the international destinations, maybe Vancouver, maybe Orlando, than in Bhubaneswar, because I call him a global diabetes consultant. He sees patients, and whenever he gets little time, flies beyond India. So I formally invite Dr. Thatoi and Dr. Satyen Kar, and I formally invite Dr. Dheeraj Panda, our rapporteur. Our moderators will introduce the faculties. Then faculties will present for 15 minutes. We have 4 sessions. This is half an hour, 4 sessions of 4 speakers. We have 15 minutes presentation followed by 15 minutes interaction. Why we have kept that? To clear all your doubts in the subject. So at the end of each session, rapporteur has to sum up the whole discussion and give the message. So better if you come, yeah, come back here. Shamim, get a chair for our report here also. Okay. So over to moderators, Professor Thatoi and Dr. Kar, for introduction of our faculties. And I'm sure whatever questions are there, we are not giving you papers, but you can stand up and ask and interact. What we want, that interaction, interaction and interaction. So half of the time is kept for interaction. Any doubt in any device, anyway, you can ask. They are operating at the global level and they are certified AI specialist. I'll tell that not only MD or DM, they are having the best degree of the world in the artificial intelligence and digital diabetes. Over to Dr. Thatoi and Dr. Kar. Actually, our workshop chair has fixed a different flow of talks that we can take up because he'll be speaking at the end regarding the ethics, regulations and explainable AI for medicine. That's of course the final word. But before that, we can take with Amit. Yeah. We can take with Amit the decoding of the basics of artificial intelligence and artificial intelligence in healthcare, the current state of challenges by Dr. Debasis. And when Shanshid will come, he will take up his topic. So over to the moderators.
Thank you. Yeah, let us ready, huh? Okay. Good afternoon, everybody. Respected delegates and yeah. So without much wasting time, I will invite Dr. Amit Kumar De, consultant physician, diabetologist, obesity metabolic disorder from Kolkata. He has 12 years experience on clinical practice with diabetes mellitus, winner of Diabetes Awareness Initiative Award in Diabetes India 2020. He is a winner of JPF 2023 Award for improving diabetes care through technology. So we know the era is now artificial intelligence. So focusing tomorrow, many people we do not know what is artificial intelligence and how it helps in particularly healthcare system. So many things are there. So I will invite Dr. Amit Kumar De to please proceed. Thank you, sir.
Okay, so I think I'm audible to the back, so I'll just come over here and I'll just be very candid with you. I'm Dr. Amit De, I'm from the city of Kolkata, and I can see a lot of curious faces trying to understand what exactly we're going to be talking about here. So while the slides get ready, he needs to plug in the part of the technology. Let's try to understand from, I guess I'm audible at the back as well, ma'am? Yeah, great. So let's try to understand a little about how we understand about what is happening in the domain of artificial intelligence around us. So my first question to all of you is, and let's make this interactive because this is a workshop, how many of us have explored using some form of AI in our day-to-day life or activities? Anything, in any form. Can I have a raise of hands? Great. So we have got about 50% of us who have used AI in our day-to-day productivity. Now, when you say you've used AI, would I be right in understanding that most of it is in the form of ChatGPT? Yes. Have we heard of ChatGPT? How many of us have heard of ChatGPT? Okay. This side, we have not heard of ChatGPT. We have heard of ChatGPT. How many of us have used ChatGPT? Great. How many of you use ChatGPT to do a search? Like you search about an article or a text or any PubMed literature. We used to do that on Google, right? So how many of us are now using it to search it on any medical query on ChatGPT? Right. Can anybody give me an idea? Okay, it's there. We are here. Okay. What form of AI does ChatGPT use? What is the type of AI that we are talking about that is used in ChatGPT? Sir? Dr. Behra?
I cannot tell that, but I use that.
You use that.
Generative
Yes.
AI.
Generative AI. So what does it
Generative
mean?
AI.
It means it generates certain content. So now, what I'm going to do over the next 15-20 minutes allotted to me by Professor Panda is give you those basic nuances of what exactly these terminologies mean. As clinicians, as doctors, we've been all trained and we have all learned to follow reasoning and follow evidence-based medicine. So even when we're using AI, we're going to use it with a lot of reasoning, with a lot of understanding on the context and the subject, and we're going to reason at every time that why we are using this particular form of AI and why we're not using the other one, right? So that's my job, to give you a basic understanding of AI. So a small disclosure from my side, and I'll take you through my presentation in 15 to 20 minutes. Is this working, the slide changer? Is this working?
I don't think so. Okay, it's not a unit with a... You wanted the light changer? Not that.
No, that's okay. If it works, it's good, then I can do it. This one? Will it work? Yeah, perfect. So, over the next 15 to 20 minutes, I'm going to give you an introduction to understand the basics of artificial intelligence. We'll try to understand some of the basic terminologies. We will try to understand and decipher these terms for us. And then we're going to try and understand that why and where we need to start with artificial intelligence. So if you try to define AI, what is there around us, what it means is that it's a machine language that is trying to understand, learn, reason, and then help you make decisions or solve problems. That is a simplest way of defining artificial intelligence. If you look at the whole spectrum of healthcare, these 8 blocks that you see on the screen is where you're going to find the maximum applications of artificial intelligence. So you will find the use cases of AI in personalized treatment, and this is why we are interested to use AI in diabetes care, because we know it is individualized treatment. That's what we have learned. And now we want to get into more of a precision diabetes care with personalized treatment. You will use a lot of AI in virtual health assistant, and trust me, this is going to give you a lot of asset when you're using it in diabetes self-management education, which is a very, very big entity for better diabetes care. We are already using AI in medical imaging, in radiology. You will get a lot of predictive analytics coming from machine learning and deep learning. We will go into these terms as we progress. You will find a lot of AI in drug discovery, in optimizing treatment, again with personalized precision medicine. Robotics will come, integrated with AI, optimizing surgery. We are already having robotic surgery. And you will have enhanced telemedicine with remote AI monitoring. So these are the 8 blocks. Maybe there will be more, but these are the 8 blocks that comes to our mind when we are looking at integrating AI into the field of healthcare. So now where do we stand? Standing today, we are in a phase where you can train a particular AI model on a particular domain and it can work good. So we are in the phase of artificial narrow intelligence. It is expected that in the next 5 years we will progress into artificial general intelligence, which is it's going to be so called as machine intelligence, and hopefully someday we will see artificial super intelligence, which is machine consciousness. We need to understand that general intelligence means it is going to be having a flexible intelligence and it will be capable of learning various tasks. The kind of AI that we have at now, even most of your ChatGPT, is predominantly narrow AI. That is, it has been tuned and custom tuned to perform a specific task. In the domain of healthcare, we will be using more and more of narrow AI for doing specific use case specific tasks. The history of AI is very fascinating. We are talking about AI in 2024, and it all started since 2022 when OpenAI released ChatGPT. But AI is not new. It was there since 1950, since Alan Turing conducted the Turing test, and John McCarthy actually coined the term of artificial intelligence in the year 1957. Since there has been multiple evolutions happening in the field of AI, and especially the development of machine learning in the year 2000. But the whole paradigm changed when there was development of generative AI. This is what your ChatGPT uses because it generates content in the year 2022, and then it opened up a huge prospect because generative AI was made open to the public. So anybody could use it through an open platform, and that's where we started thinking that can it empower clinicians and doctors towards better patient care. So now if you try to decipher this whole Venn diagram of artificial intelligence, let's look at what does these terms mean. So a part of AI is something called machine learning, and machine learning is the basic of AI. All AI tools, whether it is generative AI, whether it is your retinopathy tool, they all use a form of machine learning. A subset of machine learning is deep learning, which is based on the neural networks or the neural networks of our brain. So if I try to simplify this, you will see artificial intelligence, there's a subset of machine learning, deep learning is a subset of machine learning, generative AI is a subset of deep learning, and that's where your ChatGPT comes. Okay? So now, let's look at some of these terms. How many of you use Google Photos? We use Google Photos, right? So what happens? What does Google Photo do? It takes your photo, and once you tell it that take this image and club it into one folder, it clubs all your photos into one folder. It takes your family photos and clubs it into one folder. How does it do that? It does it by pattern recognition. So it recognizes the pattern on your face, and that is what is exactly used in computer vision. And the whole concept of machine learning and deep learning is based on computer vision. So machine learning is basically recognizing these patterns and making predictions. It is kind of an advanced statistics. We've all used biostatistics. Machine learning is just going to augment biostatistics in the field of healthcare. Deep learning is somewhat similar to machine learning. It's just a part of machine learning. It's a subset of machine learning, but it is using neural networks. I'll give you an example. In the next slide, you will understand deep learning better. So machine learning has got three parts. One is supervised, unsupervised, and reinforcement learning. To cut the long story short and make it easy for you to understand, by the name you understand, in supervised learning, you are basically instructing the machine to learn in a specific manner. You're saying 2 plus 2 is 4, and it is learning to make 2 plus 2 4. In unsupervised learning, you're allowing the machine to learn on its own and then correct itself on the response that it gets. So that is unsupervised learning, which is not always explainable. Supervised learning is always explainable. Reinforcement learning is actually a space where the machine learns, relearns from its own mistakes, and it is rewarded. So it works on a reward mechanism. This is a graph which looks at the various applications of machine learning and in terms of supervised, unsupervised, or reinforcement learning. I was talking about reinforcement learning, and this is the most important slide because we will be using a lot of reinforcement learning in healthcare. It works on a reward, an action, and a state mechanism. So it gets rewarded with a positive reward when it gives the right answer, and it gets a negative reward when it gets the wrong answer. And that is how it gets fine-tuned into learning to give you a better answer. This is how the AI tool that you use gets smarter and more personalized to your needs-specific queries. This is why your ChatGPT gets its memory updated. Now we are talking about neural networks. This is how a neural network looks like. A deep neural network has got multiple layers: input, hidden layer, and the output layer. And in machine learning, you have a layer where there is a pre-processing happening. There is a place where extraction of the features are taking place, and this is where extractive AI is used. And then the models are used, which are various machine learning algorithms, to give you an output. Deep learning is just the same. It's a form of machine learning, but instead of putting it through feature extraction and modeling, it uses the neural networks, where feature extraction and modeling is included together to give you the output. And it is said that the more the layers of the neural networks, it functions like the neural networks of our brain, the better is the output of in terms of the sensitivity or the specificity of the output generated. Take a look at this example. In X-ray, in machine learning, you're trying to do a feature extraction. You're trying to classify whether it's TB or not TB, right? That's what it is. So this is simple machine learning. Deep learning is just the same. Takes the picture, puts it through the neural network, and you're classifying as a positive or a negative output, whether it's TB or not. Deep learning has got two types: convolutional neural network and recurrent neural network. Know the terms at the moment. It's going to be Latin and Greek initially when you get introduced to it. Happened to me also 7 years back. But the simplified way of remembering is all the radiology use cases of AI, especially if you're looking at interpreting a CT scan, MRI scan, or an X-ray is going to be using a CNN or a convolutional neural network. Wherever it is involving a dynamic time series data, for example in ECG, it will be using a recurrent neural network because it's going to be time series manner. So this is somewhat a basic understanding of machine and deep learning. Let's look at generative AI. I told you what generative AI means. It means that it generates content, right? So it takes in your input, organizes it, reasons it, and it generates content. And the science is generative AI. The application is in the form of large language models. So you must have heard the term LLM everywhere it is written. What does it mean? It means it is large. Large means it's built on a large foundation data set. It's a language model. Why it's a language model? Because it uses natural language processing. I'll explain what that is. And it's a model because it's built on a transformer model. So that's how it comes as a large language model. Similarly, we have small and medium language model which are built on smaller data sets. Now the most interesting part is NLP, and this is where the use cases come in healthcare. Because NLP means, in simple terms, the computer takes the instruction in your language, it converts it into its own binary code, and then it responds back into the language of back in your language. So that is what natural language processing means. It basically means you're chatting with the computer or with the system which has the ability to reason out. In generative AI, you will have two forms that we commonly use. One is predictive generative AI, which makes the predictions, and the other one is conversational generative AI. And this is the form of AI that you are using in your chat GPT. So it is the conversational form of generative AI. Well, how does this whole foundation model works in generative AI? So you give the input in the form of text, image, speech. Now it is multimodal. So any form of text, image, and speech can get converted into any other form of text, image, speech, audio, or video. It runs through the foundation model, involves the layers of deep learning, reinforcement learning, which I just showed you. And then the output is given to you. But this output actually includes natural language processing. So that's what natural language processing means. It is an interaction between the computer and the human in your terms and in your language. So for natural language processing, we need something called prompting, which means giving the instruction to the computer in a way in which it is easy for it to comprehend. That is called prompting. The science is called prompt engineering. And if you don't give the right prompt, the instruction which you give to your chat GPT, then you can have your chat GPT end up in hallucination. So it ends up giving you a wrong information or a wrong or a biased answer. Again, when we're using in healthcare, we have to be very careful that we give the right prompt because the whole output depends upon the prompt. Sometimes you get frustrated that I'm not getting the desired response from GPT because it's not giving you the right, you're not entered the right prompt and you end up getting a hallucinated answer. So now where do you start with AI? And the first question to ask is, why do we even need AI? Why Dr. Panda has organized an AI workshop right on this Friday and all of you are here to attend this? The reason is this. This is the reason. This is the basic reason. All we've been doing so far through the last 50 years, 100 years maybe, is follow evidence-based medicine. What AI is going to do is going to take us one step ahead, deeper to look into the iceberg, and we're going to get data-driven, intelligence-based precision medicine. And this is not possible without AI. This is why we need to have AI with us. So where will these data come from? These are going to be all the data sources. Structured data will be coming from here, from your wearables, from smart watches, from your smart Apple watches, or from your smart socks, the smart meters. And now you'll also have the artificial pancreas or the insulin pumps and the CGMs, which are going to have AI enabling coming with it. Now you understand how does this work. So your input layer goes through a layer of analysis. Now that analysis can be deep learning, machine learning, or through a transformer model using a complexity of all these in generative AI, and then it gives you an output in the form of classification, prediction, generation of image, audio, or video. So this is a basic understanding of how AI works. As a healthcare professional, where do we start from? And why do we need to even know about it? Start with the foundation knowledge. That's what you're doing today. You have the basics of AI, data science principles, learn the relevant algorithms, and then we start using it into our activities, things that we do. You start innovating. At every point, we need to keep the ethical considerations in mind, but remember, the practical steps is to identify the clinical needs and collaborate with AI expert with continuous learning and adaptation. So what AI is going to do is going to help you see what you have been missing, and this is the biggest advantage of using AI. Now, just to give an introduction to the next speakers, these are some of the challenges that we face in diabetes care, and we believe that AI has this opportunity of being used in these places in diabetes care. In disease prediction and risk stratification, you can use machine learning and deep learning. Now you know the terms. Diabetes self-management education, you can use the AI chatbots through generative AI. Insulin pumps has got AI, Dr. Debashish works on it. We have diabetic retinopathy screening that uses deep learning. Foot ulcer management can be done with deep learning and machine learning, and you will have clinical decision support system that uses the complexities of all these networks. So let's look at a little bit, let me take you forward. This is the introduction to ChatGPT. I will skip this. But let me give you an example how you can use these generative AI tools into your daily practice. And before I end, allow me to introduce you to something which is very interesting. Now see, this is something which we have worked on. We've used ChatGPT to analyze a continuous glucose monitoring graph. You can use it, feed it, and it just gives you a summary. For example, this is a CGM graph. You would be all familiar to it. We have trained a ChatGPT model to analyze and summarize this graph, and then you end up getting this kind of a summary. It just summarizes the whole graph and makes it easy to understand, especially for a healthcare provider or a support staff, right? So this is called the CGMS guide. If you have your phone, you can scan this QR code and you can start using it. This is available to ChatGPT Plus users. So if you're a GPT Plus users, you can start using it, and this is trained on a 100 plus continuous glucose monitoring data. This is a paper that we published which has got the whole understanding of how you can use a simple tool like ChatGPT, which is available on your mobile phone, for improving diabetes care in your patients right now. And before I end, I'm going to introduce you to something that we all developed as a team. Dr. Alok is a part of this research. Please scan this QR code. This will enable you to use AI right at the moment through your WhatsApp. We have developed a tool called Madhu AI, which is Metabolic and Diabetes Health Assistance. As you scan this, you will see that it will take you to a link, and you tap on it, takes you to your WhatsApp. It's India's first AI produced using on the WhatsApp user interface. But the important part is we have validated the response of it. So it has been validated in 3 stages. At the moment, we are trying to do the patient use validation, which is more like a trial. It is a human validation of the AI response. So this is how it looks like. I'll just take you through this before I end. So I don't think I will be able to scroll forward. So it takes you to your chat bot, it takes you to your WhatsApp, and you just have to write "Hi Madhu," that's an automated prompt, and then you give an instruction to it, and it gives you an answer as for patient education. So you can ask this in any language, you will get the response. You can just try doing it, and I'm here if you have any sort of a query or problem happening, you can ask me. Just scan this QR code and you can start using Madhu right away. So with this, I would like to sort of take a snapshot of this tool before I end. This gives you an access to all the most common available AI tools that you can start using right away. You have Perplexity, you have Quillboard, very useful for paper writing. You have Gamma to prepare presentation. In fact, this whole presentation has been made with AI. You have Claude, which is another AI tool. Llama 3 is, of course, now 3.1 is there right on your WhatsApp. Tome is also used for creating PowerPoint presentation. Copilot can be used for generating images. So this is a quick snapshot to have if you start wanting to use AI right away. Okay, this is a very interesting hub where you can get all the AI tools. Take a snapshot of this. This is a generative AI kind of a Play Store, like a Play Store or an Apple Store. You get all the apps, so here you have all the AI tools which are available, and you can find your use case AI tools to improve your productivity. So these are my 2 tips to our audiences today as to how you can start using AI right away, and that is Madhu. So with this, I will invite all of you to be a part of the Doctors AI community. It's a community we are building. Alok, myself, Debashish, we are all a part of this community. And we now have over 1,100 global members. We just had a podcast with Dr. Joshi and Dr. Jyoti Dev. It's a fantastic podcast. You can hear this. This is the QR code to all our podcasts we conducted every 15 days. You can just have a look at this podcast that will get you started with AI. And of course, this is the community link. This is our LinkedIn community link. So please join us on the LinkedIn community. And if you are not on LinkedIn, then this is the link to our WhatsApp community group. So now we'll invite all of you to be there with us. And it's just the start of the AI journey. And as we go forward, we keep learning more and more. And I will end by inviting all of you to join us at the AI Virtual Summit, which we will be doing it in 14th and 15th of December. That is going to be the Doctors AI Global Summit. This is going to be our first summit. It's going to be virtual and open access for all people across the globe. Thank you very much.
Thank you, Dr. De, for keeping us through the journey of AI. I request audience for 1 to 2 questions, because after all the sessions we will go for the panel discussion. So any questions from the audience?
I think it's a time where everybody is just absorbing it in, so questions may not come immediately. So while
So
we
we'll take questions after.
Yeah, I
after
guess that'll be better.
The end of the session, we'll take the questions. Next on the panel is
Oh, you want this laptop? No, then I'll leave it here. No. It's fine. Give this also to the Ashish. What's happening?
So it's my pleasure to welcome Dr. Devashish Das, my welcome as senior from MKCG. The topic is artificial intelligence in healthcare, current state and challenges. Dr. Devashish completed MD Pharmacology from AIIMS New Delhi and diabetes from US and UK. He is consultant physician and diabetology working in Mumbai, the medical affair of Asia Pacific Medtronics. So he has a lot of international exposure in this field. So without wasting your time, let's welcome Dr. Devashish.
Hello, good afternoon to all of you. Thank you, Dheeraj. First of all, I would like to thank Joyant Bhai and the whole organizers of RSSDI ODISHA chapter to invite me to speak on AI, especially in healthcare, very close to my heart. I work on some of the products which are basically AI and ML driven in the field of diabetes. Also fortunate to be here in front of my teacher, Professor Sitaram Mahapatra. He was one of our favorite teacher and one of the best teachers who taught us in the field of pathology. Very fortunate to be here. So thank you for being here. With that note, I would start. So my topic, I think Amit set a very good stage about explaining. I know a lot of things must have bounced also. Nothing to worry. It happens. We all go through the same thing. So nothing to worry for that. We keep learning. So I will try to just take a step further to show what exactly AI can do in healthcare and what's the current status in the entire healthcare and the challenges. Just my disclosure, I'm a full-time employee of Medtronic, Asia Pacific, but no disclosure for this presentation because I'm presenting in general about healthcare. Now, I think already Amit has shown. I'll just again reinforce because I know these terms might be new for few. In very simple terms, AI means a machine or a program that can sense, reason, act, adapt, mimic human behavior. Subset of that or AI works on machine learning, which is learning a predictive model from a data, input data, to make a useful predictions from something new which you have never seen. The third part, or which is subset of again machine learning, could be deep learning, similar but it uses neural networks. You put an input, it will give you output, but it uses the, and why neural networks? It is same like our neural networks in the brain. That's why the name is neural networks. It's layer by layer and you get the output. That's called deep learning. So artificial intelligence is whole. Artificial intelligence uses machine learning or deep learning. So the entire gamut is called AI, but the subsets are called, like you can call medicine. Under medicine you have pharmacology, you have pathology. So AI is whole medicine. Now, if you see AI is a technology. It is very fast. It is running like a rabbit. And the same time, as clinicians or as regulators, we are tortoise because we rely on clinical evidence, evidence-based medicine. Regulations need time. So so that is the challenge with technology, and so adoption of technology is taking time because of that. Technology, a new version of app comes in every 2 months. But then as clinicians or as regulators, you cannot adapt it so fast. You need some data or evidence to show you, okay, this is good enough to be adapted. So that is why, so it takes a lot of time. So that is why adoption of these technologies take a certain amount of time, both from a regulator point of view and also from a healthcare professional point of view. We cannot just go blindly. That is why in healthcare, we need evidence to show, yes, AI or using AI is either increasing your efficiency or is improving diagnosis or prevention or treatment or outcome. So this is how the path, technology and this one. At the end, we have to see, just for the sake of AI, don't adopt AI. If it is adding value, then only you add AI, correct? Just for the sake, don't. Any technology, not only AI, any technology. It should add value for patients. It should be simplified. It should be better outcomes. For providers, for doctors like us, it should increase decision making. It should make our jobs easy. And for institutions, it should make, again, growth and efficiency. Now, already Amit has shown this, so I will just show picturally. This is traditional algorithm, machine learning and deep learning. He has already described. This is just a simple way to show what is a traditional algorithm which we used to use long time. Now machine learning, and this is deep learning. Now, as Amit has shown you, AI is not new. AI was introduced in 1950s. But it could not take off. Why? Because we did not have so much of big capacity of hardware. That time the hardware capacity was 30 GB. Now we can handle thousands of GB. So the driving forces currently for AI is advances in computer hardware. We can handle huge amount of data in terms of capacity, I'm telling. Second, now we have availability of huge volume of data in any field, whether it's healthcare, whether it's retail, whether it's anything else. We have now better algorithms. Then we have machine learning solutions to see the problems better. And then we have now better sensors, like sensors on the watch or sensor here, which can just capture your heart rate and send across to your physician or to the system. So because of these, you have now the AI is being expanded like anything because of this. Advances in computer hardware, huge volume of data, better algorithms and better sensors. Now, these are the basic steps to make an AI product. If some of you are planning to make AI product, this is how you make. You first decide a clinical need, whether you have a need. We have to first define the problem. Then you look at data, which data you need, collect the data, store it, annotate it. Annotate means chicken tarkari chicken to marinate kurchunti. Annotation is that you prepare it towards that. Okay, and then your data is clean the data, Then you make an algorithm, train the algorithm, validate it again, pass through the regulatory body, deploy it as a pilot project or phase wise, then you have a monitoring system to regularly update it. Then only you have a successful AI product. You need all this. So what is key for AI? Data. Good amount of data. जितने अधिक data होगा, सेते आपनका outcome भलो. Not only raw quantity, quality also. You need good quality data. Then only you will have a robust machine learning algorithm or AI. यदि data न थी वो, garbage in, garbage out. Simple. That is why, as is shown, which area is working most? Radiology. कहीं की radiology रे ultrasound pictures अच्छी, CT scans of pictures अच्छी, MRI which is very clean and annotated. So 70-80% of the applications currently is imaging. That is why imaging. So you need good quantity and quality data. Now already shown dimensions of AI. It could be strength, how intelligent is it, what's the breadth. So you should know what AI can do. AI cannot do everything. You should know what AI can do. Training, how it learns, what are the capabilities of this AI, what kind of problem it can solve. And then autonomy. Can it work on its own or it needs input from you? And these are some of the ways which basically why AI being used. One is improved diagnosis, which I already shown, effectiveness, managing population health, hospital operations, managing manufacturing operations, and post-market activities. And there are multiple of things you can do from AI. I will touch some of them, which is already there in already introduced in the market and being used across the globe. And these are some of the top 10 AI applications in healthcare. This is just a picture I have taken, basically into risk advisory, financial and clinical decision support system, medical imaging, drug discovery, already has shown you, so I will not go into more into that. As I have shown you, this is the current use of AI. So if you use AI, standard method will just tell you it's a polyp. But with the AI, it will tell, okay, 70% chance it is benign, 30% chance it is malignant. That AI can tell you. How it can tell you? You pull all the data. You have, for example, you have 1 lakh pictures of polyps, okay? And you know from 1 lakh, 60,000 is malignant and 40,000 is benign. You put all the data into the system. Raw data को pass करो same system रे, it will tell you कि भैया okay 70% chance this is benign. So that is how AI works. So का ऊपर base करूँची data. So you need good data. यदि data नहीं, AI will not work. Same it can be during COVID. It was used a lot. It was used for tracing contacts, for surveillance. A lot it was used during COVID. Pharma, a lot being used in pharma, especially drug discovery, pharmacokinetic studies, pharmacodynamic studies, identifying new molecules. Now you have 1 lakh NCs, new chemical entities. So you can run through that program and it can tell you, okay, out of this 1 lakh, this 5,000 could be potential drugs. Then you can scan, go from there. We used to call high throughput screening. Now AI will be built into high throughput to have a better outcome. Now, already Amit has shown you, there are some of the opportunities in medical device. Early detection, more accurate diagnosis, new insights, and personalized treatment. And this is just picture from FDA, as I told, 70% is radiology, 30% is cardiology. And some of them, and then ophthalmology, retinopathy, because you need again picture. You can have identify. So if you have a picture from a retinopathy from a diabetic patient and you run through that AI, it will tell you, okay, 70% okay, no DR, it will tell you, yes, DR is there. So, jar or DR achi, then you can send him to a retina specialist for further workup. So it makes your job easy. As of today, not as of today, as of October 2023, US FDA has approved 700 AI-enabled devices already. It's in the market. Aji August to 2024, there might be 1,000 now. So in that way, it is progressing a lot. This is one of the example of a non-imaging AI. Apple Watch, from your heart rate, it can tell you whether it's AFib or not. Just, and that will go to the user and it could be transmitted to your physician. Second, also you can have this one, another lab murmur, just from your, again, heart sounds stethoscope, each stethoscope, it can tell you whether the person has a murmur or not. Amit's shown you about diabetes. So AI enabled insulin pumps, or what we call automated insulin delivery systems. These are 5 of them in the world, and this is the one available in India. So you just put a glucose sensor on the body. The glucose sensor data will go to the pump. There is an algorithm within, and automatically it will deliver basal and corrections. As of now, it's a game changer for type 1 diabetes. You ask Dr. Bansi Sabu or Dr. Mohan. Dr. Mohan Center has now 200 patients, and in India 2,000 patients. They had not seen a type 1 diabetes with time in range of 80-90%. Now with this AI enabled device, we have seen type 1 people, teenagers, getting 80-90% time in range without hypoglycemia. Significant. That is the change AI can give it. Manually we could not do it. So it's a game changer for type 1 diabetes. It automatically delivers basal and bolus. It works on this technology, algorithm called PID, proportional integral derivative with insulin feedback, and it has some component of model prediction also. It works on that. And as I said, already it's available in 100+ countries, and I am one of them working on this product for last 3 years, and we are coming with a new version soon. It's fully automatic. You don't need any input to that. Not only, you don't need a meal input also. It will automatically decide how much you're eating, and it will even push the post-meal insulin requirement. And it is available globally, as I'm saying. It is doing globally very well across. Initially, we launched it in Europe. When it came to Asia, I was a little apprehensive. European people don't eat so much of carbs, but we eat a lot of carbs. Will it work in Asia? But I was surprised to see it worked so wonderfully in Thailand, Philippines, Singapore, Malaysia, who eat a lot of carbs. In India, we have 2,000 patients, and time in range is fantastic. I'll show you some of the India data. This is India data. I have 750 patients data now. On an average, time in range is 73.5. If they use the recommended settings, it's close to 80%, and going well, very well. This is another product in Medtronic we call GI Genius, again launched. It is colonoscopy with AI. So during the procedure only, when the surgeon will see the colonoscopy picture, AI will tell whether it is benign or malignant. So it is AI-based, first FDA AI-based colonoscopy. Then we also have a risk analysis and data analytics, that is for heart failure, available in the market already. Physicians are using, cardiologists. This one is for your screening of heart valve disease, again same, helping physicians to make better decision making. And then we also have another platform called LinkQ, which works on AI platform AccuRhythm, that if the heart rate goes, it will tell you better whether the patient is having what sort of arterial flutter or fibrillation. And this one is in stroke. We have a app called AI-based stroke detection app. It goes through again AI algorithm, and it can tell you the prediction for stroke and the allied things, how to manage it, and which therapeutic intervention will be better for this patient. This is another one for basically for your decision making, for your deep brain stimulation, for neurosurgeons who use it. Again, it has an algorithm and it helps in better this one. And Amit show you, this is the robotic system, AI enabled robotic system called Hugo. It's from Medtronic, but we have Da Vinci and others also. They are also now new ones from Intuitive. They also work on AI based robotics. So AI has entered everywhere, so you can't escape it. If you are a clinician, you need to adapt it. You need to learn it, how to use. Already he has shown the future is Gen AI. Already he has shown. And this is how a Gen AI works. It is artificial intelligence trained on vast amounts of information. You can see the training data, pictures, and then this is your trained AI, and then you put an input, create a picture of a river next to the mountain. You can see the output. The AI will give you picture of the river and people on the mountain. This is Gen AI, which will give you this one. This is in general. This is the latest one. I just could get, this was launched in 19th July 2024. Third CII Digital Health Summit happened in Delhi. This is a made in India robot, Gen AI. Her name is Ria, made by a Bangalore company. You can place it in hospital. It will interact with the patients, will make them understand what is their issue. Even it does counseling. This is real world, made in India, just shown at the CII. And ministry was there. So you can see the power of AI and how much it is now adapted. Again, living in AI powered world, everything is not rosy. You have technical challenges, you have social challenges, you have legal challenges, you have safety challenges, and you confronting again the challenges, how you do it. These are the basic technical challenges. Bias is very common. Sampling of data, labeling of data, decision making. Vulnerability, cyber attacks, deep fakes. You have seen deep fakes, again a big problem. Deep images, deep fakes, again a technical challenges. Bias, already I've shown you. And bias can be at any moment. From data collection, for example, how it bias? For example, you are working in some hospital. You have just taken the data of some hospital. That particular department. That might not work in Puri Jagannath Hospital, because data is from some hospital patients. So that will be a bias. So if you need to use it across this area, you need to have patients from across the hospitals. So that is bias. If you take only elderly and apply it generally, it will not happen. So bias can happen at any moment, from data collection to deployment. And that's the most common challenge. Legal challenges, all of us know. There are privacy issues. I think Dr. Alok will take that. Privacy, right to explanation, discrimination, all that are legal challenges. Safety challenges. It's like self-driving cars. Okay, so you have safety challenges. Again, remember, AI works on consistency. Novelty is a problem. So do not try to make novelty through AI. Fundamental, very, very important is transparency. Whether you are a developer or a user or a patient, you need to be transparent in saying what AI can do, what your AI cannot do. You have to be very clear. You have to be very transparent to regulators, what data you have taken it and what data you have not taken it. If you do not if you do not keep transparency, it will be a huge problem when you come to implementation. Should you be scared of AI? No. Prepared? Yes. Because you don't have a choice. Yes. What are the strategies? How to confront the challenges? Stay relevant. Adopt a lifelong learning attitude. You have to learn. You don't have a choice. You have to learn. If you don't learn, you will be sidelined. It's like Nokia and Samsung story. Nokia kolla ni Nokia rohigala, Samsung agu gala hari. Same story will happen to every one of us. To conclude, AI will impact every area of human activity, every area, not only healthcare, in general. You put Google, there is AI. You just put one word, it will give you options. How is that happening? It's AI. So it's a Gen AI. Again, you should know there is still a lot that AI cannot do. What I want to tell you before I close, AI can't do well, perform any entire job better than humans can. Number one, explain its mechanism for finding patterns in information for what those patterns mean. Understand the context that surrounds a given task. It cannot. It cannot learn from unorganized, unlabeled or small amount of data. It has to be organized, it has to be cleaned, it has to be marinated and good quality data. Otherwise AI will not work. And it cannot perform tasks that require creativity, empathy or complex judgment. That is only human intelligence can do. You don't rely AI for these things. AI is only work for consistency. Repeated works. not novelty. AI in healthcare is here to stay. Thank you very much for a patient hearing.
Thank you, Dr. Devashish, for the wonderful presentation. So we will take the question after the final session. So our next topic is application of AI in diabetic and metabolic care. For that, it's my pleasure to invite Dr. Swayamsid Mangaraj, Professor, Department of Endocrinology, IMS St. Tom Hospital. He is the national runner of ESI TAS 2016. He has 46 national and international publications. Awarded first prize in best oral paper presentation at ITSCON 2019. So over to Dr. Mangaraj.
So good afternoon, everyone. At the outset, I would like to thank the organizing team, especially Jayan sir, for having me over here. So I think we have listened to two beautiful talks elucidating the role of modern AI and healthcare. And Dr. Amit and Dr. Devashish have done my job a bit easier. So I will not dwell into details of what basic AI is or what a generative AI is. Narrative regarding the utility of AI in healthcare is also discussed. So I will just tell you in the next 15 to 20 minutes what is the scope of the problem which we have with diabetes as a chronic care segment disease, what are the opportunities that perhaps AI can solve for us, what already has been achieved, and what the future looks like. So I think AI is here for all. I would agree with the last statement that you need not be scared with AI, but if you do not learn and accept AI, then perhaps you are going to be in the back burner. So I will start with the wise words of one of the gifted and most talented persons to ever have graced earth, is Leonardo da Vinci. So he told that the greatest deception man suffers is from their own opinions. So this statement tells you that things which you do not believe or per se are made to believe might not be true, and that perhaps what AI has changed over the years. So now let's dwell in the realm of AI. So this is what current application of machine intelligence in diabetes care and research looks like. So I think Dr. Amit has told you, utilizing these machine learning models and algorithms, both with supervised and unsupervised learning, that has a role in across every domain of modern medicine. You talk of basic clinical research, drug development, translational research, or your clinical practice. Each of these facets of healthcare is going to be transformed by AI in the next decade. Now, these are the main 8 domains of diabetes in which AI can play a very crucial role. The first is diabetes management and treatment. I will show data, what we have published, data we have as of 2024. Diagnostics and imaging, obviously the brainchild where perhaps we had seen so many advancements in a generative AI, healthcare monitoring systems, developing predictive models which may have a significant role to play, especially in designing principles for primordial or primary prevention at population level. Then public healthcare interventions, prevention strategies including lifestyle and dietary management. I will talk you what is known as precision medicine. Many of you would have listen to those, but what is precision nutrition and how AI is going to modulate that precision nutrition. Then enhancing, look, AI is there for us and it is going to help us in delivering better care. So AI enabled clinical decision making tools are going to be the norm. As you see clinical practice guidelines published in all domains of medicine, similar kind of guidelines would also come up in future which utilizes AI. And the last is patient engagement and self-management. So just starting from the screening of diabetes. So if you talk of a population level, which subset of population, because if you talk about the spectrum of diabetes or the prevalence, so roughly as India 10% of the entire population has diabetes, equal number of people have pre-diabetes. So needless to say, those figures are discussed n number times, the major brunt of diabetes is going to be borne by low middle economic countries. It has changed the landscape from developed nations to more developing and middle economic nations. Now, classifying diabetes, we have seen patients who are misclassified as type 2, put on OADs, then switch to insulin after years or decades together. By the time the patient lands up in chronic complications, that has perhaps can be changed by utilizing AI. So the classification, whether it is a LADA or it is a MODI or it is a type 2, lean type 2, those can be stratified by using AI. Similarly, we now are aware of clusters of type 2. So type 2 is not a homogeneous disease, it has its own clusters, well published by the data from both India and abroad. Mohan et al. Has published data from India looking at the different subtypes of type 2 diabetes, because based on that you are going to prognosticate what complications the patient is likely to land up and what drugs are going to work. Then regarding AI mediated diet monitoring, AI mediated diet recommendation and AI prescribed physical activity. Next frontier is how do you optimize blood glucose monitoring with regards to monitoring as we do from SMBG to CGMS, blood glucose prediction, essential tool for especially when you use pumps, demonstration of adverse glycemic events, then whether AI can do insulin dosing as we physicians do. I will show you data how AI fares versus novice physicians to top-end endocrinologists, how it fares in the real one clinical settings. So this is just a snapshot of what AI can transform from screening, prevention, diagnosis, prognosis and treatment. Each of these domains can be perhaps transformed by using AI. Okay, so by the time he puts up a charger, so this is what is known as personalized medicine. So AI has a big role to play in that. So when we talk of personalized medicine, this is what we talk of. So now we know modern healthcare has its own demerits, modern medicine has its own demerits, because one theory doesn't fit all. We have to take into account many things by the time we actually advise a management protocol. So precision medicine takes into account your ethnicity, geography, genetic background, food, exercise, everything. Then it generates a prescription which is not only better suited for you with lesser side effects, more optimization of time and drug and better results. So all of these prevention, diagnostics, treatment can be actually revolutionized by utilizing AI. So this is known as precision nutrition. We have talked about precision medicine, but what is precision nutrition? Taking into the data of your genome, epigenome and transcriptome, these are big data. Once you have those data, then you can pull it and stratify your patient's group. Then you can tell, look, this subset of diet like Mediterranean diet, DASH diet or any Indian diet is better suited for you. You cannot prescribe a simple diet because diet is something which is very different across geographies and ethnicities. You cannot prescribe a single diet. So this is the next gen. By the machine learning algorithm, it is going to devise you a particular diet which may be better suited to you. So this is the concept of precision nutrition. I will talk of complications. Now here the poster child is diabetic retinopathy, because this is the first thing which has been revolutionized by utility of AI as in diagnostics of radiology. So what here you can see, with a mere photograph of a fundus of the macula and the fundus, people sitting at US can look at a villager residing in Kandhamal. Only one thing they need to understand, you have to have a device which can take those photographs. You do not need anything else, a good internet connection and their device. So this is how it has revolutionized. Nobody believed initially that perhaps it could transform the healthcare. I will show the data how it compares versus class A retina specialists. So this is one of the FDA approved device which we have, IDX diabetic retinopathy screening tool. It was approved in 2018 by FDA. Utilizes a fundus photography of two photographs at 45 degree, one at macula and one at the fundus. It will show you the basic purpose is to pick up two things, whether you have a sight threatening retinopathy or a advanced degree of retinopathy, because these subset of patients should be transferred earlier to a healthcare facility when appropriate treatment can be given to save their vision. If you don't have a mild DR or no DR, it doesn't make much sense. But if you pick up that vulnerable group, you are going to improve the healthcare outcomes. So how this works? So you take a photograph, it will generate by using the convolutional neural networking, it will generate what kind of retinopathy you have, mild, moderate, vision threatening, diabetic macular edema, no edema, everything it will give you. So now how it compare versus good retina specialist. This is the retrospective data published in 2023. You look at the almost of 800 patients. They have compared two available systems. One is Medios AI and IDXDR. You look at the sensitivity because it's a standard screening test. Almost 95 to 99% of the time, these are better than the standard, almost as equal of having a good retina specialist. That means these machines are doing their job perfectly well. They are picking up the cases, appropriate timely referral and timely intervention. By that, we can save the vision. So just this data summarizes how beautifully AI can be used in a productive way, not against us. These are the list. I think Dr. Debashish have told you almost more than 700 applications, AI-based applications have been approved by FDA for routine healthcare use. These are the devices approved by FDA, IART, IDXDR, Guardian Connect. I think those we have discussed already. Has shown you the slides for Minimed 780G because one of the pioneering hybrid closed loop pumps which we have at our disposal now, and the time in range which we told impossible to achieve a time in range for a diabetic type 1 youngster who is not so much consistent with the diet and insulin therapy to achieve TIR of more than 80%, but that has been achieved with these devices. So just glimpse of pumps, I will not go into detail. So this is the advanced 780G hybrid closed loop pump with integrated CGM. So this is going to driven by algorithm. You don't have to do much. There is data. Listen, insulin pump is not for all. Even if you put someone on pump couple of decades back, there is data that every child or young fellow spends more than 1.5 hours every day doing maths before taking his meal. They have to calculate insulin carb ratio, the correction factor, the bolus, the prandial, everything has to be calculated, put in manually. That has gone now. This is another system, the iLet bionic pancreas, also FDA approved. You only need to put your weight, that's it. It calculates everything, what dose has to be delivered, what basal has to be delivered. You know, no carb counting, no correctional doses, it is algorithm driven, and there is no preset basal rate. So this is how AI makes your life simple, especially for people who suffer from type 1 diabetes. Apart from that, every type 1 diabetes, especially if they want to do carb counting, they have to run through numerous things to just learn that art. That has also been taken care by AI. These are food recognition and carb counting apps. One is Go Carb and one is Go Food. What you need to do, you need to take your smartphone, take a pic, upload it in the app, then it will generate what kind of food are you eating, what carb it contains, what fat it contains, what protein it contains, what more you need. This has perhaps revolutionized how effectively that not only for type 1 but for any health enthusiast who takes nutrition very seriously. This is another app. Look how simple it has made just by using a mobile app. Here's a plate with rice and paneer. You take a pic of that, upload it, and you have the carb count, the protein count, everything. The only thing we need more data from Indian data, South Asian, Caucasian, every day, different kind of food that is being eaten, and it will give you, once the system learns that, it will give you more accurate with less inconsistency. Couple of apps are available like Go Carb and iSpy. These are available and used by people with type 1 diabetes to manage the carb counting. Now whether insulin, as physicians I can prescribe a drug, do an algorithm driven by AI can prescribe that insulin in a wise fashion. This was published in 2023. 3,200 individuals with 38,000 insulin counts were delivered in the retrospective trial. So what they have done, they have devised one artificial intelligence based insulin clinical decision support workflow, the INC DSS. This workflow they have devised, and what they have shown is, you will be surprised here, look at the agreement of premix basal insulin, this is almost kind of very, very good agreement whether you give it by physician discretion or you give by algorithm AI based discretion. There is good wide agreement on that. You look at the blood glucose values. The capillary blood glucose value improves, the preprandial blood glucose improves, the prandial blood glucose improves, and the insulin doses also improves with AI versus conventional human based dosing. That means it is not a textbook thing, it does work in real world setting. Now time for a selfie. So if I would tell you that by taking a snapshot of your face, I can predict whether you are likely to have CAD. How many of would you agree to that? Some would laugh at me if I had talked of the same thing in a conference in 2015, but if I talk of that in 2024, we have data to say that. So what the Chinese have done, the published couple of years back, but it's a very interesting study. They have devised certain areas of face. You can see forehead, nose, nasolabial folds, aging spots, ears. So just by taking a pattern recognition of photographs, what they have shown is you will be surprised. Just look at the right hand panel. At least one of the 50% stenosis, you see this one. So patient who actually had findings in the classical photos, and by this AI driven model, there was significant correlation with whether you have more than 50% stenosis, 2 vessel disease, or even 3 vessel disease. So this is, and how, now the question is, okay, we have developed an AI model, it predicts whether I can have a CAD or not based on a single face photograph, but whether that is better than the conventional tool what we use, like risk scores, CAD risk scores. So what they have shown is, you look at the downhand panel algorithm, screen is not that good. So algorithm, and if the algorithm is compared to CAD consortium clinical score or the Diamond Forrester score, it is actually better than that in predicting patients who might have CAD, which you are missed with conventional clinical scores. So now this is the feasibility and utility of deep learning. So because cardiovascular diseases are the most common cause of death and morbidity in diabetes, so this is also going to be transformed by using AI. By using tools from your background like diet, exercise, ethnicity, family history of CAD, plus your lab parameters, ECG, CT, echo, whatever you have, if those are pulled together by machine learning or deep learning, you may generate decision-making tree to predict which subset of patients might have a CAD in near future and what best strategies can be utilized to optimize the care that should be given to these patients. Now this is reinforcement learning published in Nature. So here also they have taken the EHR data in a retrospective fashion and tried to run a proof of concept trial in few individuals. So what they have shown is here is, I'll just summarize here. If you look at the performance, the right hand panel, blue ones are from the physicians. G1 is junior, G2 is middle, G3 is a senior physician or endocrinologist. If you compare AI and G1, G2, G3, AI is almost equivalent to G3. It outperforms the G1 and G2 in delivering the insulin to these type 2 individuals. And if you compare them, perhaps AI was better in performance than physicians in this small proof of concept trial. And if you look at the satisfaction agreement, the right hand panel, so satisfaction agreement is also much better in individuals who used AI. Whether a voice based conversational AI in titration of basal insulin doses. It was published in JAMA. So in these 32 individuals, it is a RCT. So there is no real level, it's just the only thing is it is a RCT, well randomized. So what they have shown is that AI group had achieved glycemic control more quickly, are more likely to adhere to the therapy, and are more likely to benefit from the AI with terms of glycemic control. So this is the data from RCT. There is no doubt in a randomized blinded fashion, they have shown that AI voice-based therapy can outperform physician in determining the algorithm for basal insulin. This was the automated insulin delivery published few months back in NEGM. So what they have shown for the first time by utilizing the ADAPT collaborative study in UK. So this device pump was beneficial to reduce maternal endpoints and give them better glycemic control versus conventional insulin dosing, and this pump utilized AI for delivering the algorithm based insulin doses. So clear enough, AI works well in patients with type 2, type 1, and also in pregnancy.
Time to sum up.
Okay, I'll just have one more slide. So this is, AI works in a very big way. This is the data from National University of Health of Singapore. The dots are people who have diabetes and CAD. Yellow dots, 7 to 10%, green dots, 7%, red dots are A1C of more than 10. Integrating the data, they can now tell where the patient is there who is likely to suffer from a CAD, target those areas. So this is now a big AI. At population level, they can tell you where you reside, which colony has a chance of having a heart attack in the next subsequent months. So this is the future of AI. Similarly for myocardial infarction, but this is very limited. People are using those particular health system, but this is definitely done. A slide from Dr. Amit. So ChatGPT can be used as a tool for health boards, health assistants. It can give you dietary guidance, exercise guidance, lifestyle tips. So this generative AI can be used for our benefit, which may cut down the work of an human. This will be talked by my next speaker. So there are opportunities like precision, prediction, and personalization that can be done with AI, but it has own caveats and own set of challenges that will be detailed in the next subsequent talk. So to conclude, AI development is a fascinating state and has a substantial progress to make in coming decades. It will impact virtually every health domain of patients and healthcare providers. We cannot be mere bystanders to the development of AI and the evolution. It is not an option at all. So we have to get involved, and through continuous training, development, and interdisciplinary approach, we may offer better AI care to our patients. Thank you all. I can take some questions if there are any.
Now we'll have the question answer session at the end, panel. Now I request the next speaker, that is on Achi. To introduce him, he will be talking on ethics, regulations, and explainable AI for medicine. Okay, and I now request Dr. Alok D. Modi to start his deliberation. He is a consultant physician and cardiodiabologist in Thane, Mumbai. He is a topper in medicine, MD medicine in St. GS Medical College and KEIM Hospital. He is a fellow of ACP, USA. He is a fellow of Indian Society of Hypertension. He has a postgraduate diploma in lipidology from South Wales University, UK. Dr. Modi, please.
इसका जरूरत नहीं ये ले लो चलो So good evening everybody, good afternoon everybody. At the outset I would like to thank Panda sir and our respected chairs and the lovely members from the organizing committee. Thank you Panda sir for the wonderful blessings I got today in the morning from Jagannath, Lord Jagannath, and a very warm welcome to all the delegates. We have had a very good discussion on AI. We have seen a wonderful talks given by esteemed faculties on what is AI all about, how to creep into life. So I always say everything comes with a sense of responsibility. It's very nice to get married, but then you have to have a sense of responsibility with your spouse and with your in-laws. Otherwise, marriages don't succeed, right? So similarly, you might be driving Maruti 800 or a simple normal car, and then finally you'll land up with a Mercedes or a Audi or something, a very wonderful thing. What happens is you become careless, you'll end up in jail, you start murdering people, so many things are there. That does not mean that you should not buy a Mercedes or an Audi. Please understand that. So what is important is you need to know how to drive properly. So I give this very clear example. A defense person has got a gun in his hand. he shoots and he kills people, but then you reward him. You call him a Deshbhakt. But when you use a gun in a wrong way, you'll end up in a jail and you might get फांसी की सजा, you know. So how you use your tool is all that matters. And my talk here is not to criticize AI, but my talk here is to tell people how to use AI in a responsible manner, and that is something we need to understand. So having understood the fantastic Audis and Mercedes that you have heard so far, let me put a little brakes on your Audis and Mercedes and show you how to become a responsible driver. So there are certain concerns. There are ethical issues and other different issues, and I'll go into those details. Bias. Is all that AI work that you're getting, is it really true? Is it fair, or is it a biased output that you're getting? If something goes wrong with AI, so no, tomorrow if you do something wrong with the treatment of your patient, you will land them in the consumer court because you have done something wrong. But when you are using an AI tool, for example, what my esteemed previous faculty told you, that you use a wonderful camera and you pick up diabetic retinopathy. Now suppose an ophthalmologist says there is a retinopathy and the AI misses a retinopathy and you go very happy and the patient becomes blind. Will the AI company pay for it, or will you pay for the problems, the complication that you're creating in your patient? So who's responsible for an AI misdemeanor? Security. AI can go into bad hands. You know, Google patients, they are a real headache for you. Tomorrow is an era coming where you'll have AI patients, and they will be very difficult to handle because there is a doctor training them, a better doctor than you, right? So how do you prevent bad actors from misusing an AI tool to create problems? And there are very lovely Hollywood movies telling you how AI tools have created havoc in the world. And the recent example was, there was a misdemeanor and all the airlines crashed across the planet, right? A little bug had come in and every system collapsed totally. So very good example. Finally, everybody wants to make money. You might say, we are not here for money, but the truth is everybody wants money. Who's making money here? Is it the developer who's making money, or is it the company which is running the AI making money? And if they are making money, how do you know that money is not being channeled for ethical uses? A very important question to be kept in mind. A clear-cut example is OpenAI. It is called OpenAI because it was open. It was supposed to be free of cost. Okay, what you're using, ChatGPT, the company behind ChatGPT is OpenAI. Okay, now 70% of that stake has come from Microsoft. Moral of the story, the moment Microsoft walks in, it is no longer free. So there is a substandard version called OpenAI, which is OpenAI. The higher version that we all buy by paying $20 per month is no longer an OpenAI. And there was a huge duel between OpenAI and Elon Musk, and you know about it. They have all both gone to courts against each other. So that's one thing to be kept in mind. Finally, it is power. Mercedes and Audis are wonderful, powerful machines. One little kick on the accelerator, you can jump from here to there. In the bargain, if you end up killing people, you will end up in a lot of problems. You will also jump from your house to the jail. So who's got that power and who's controlling this power, and how do you control the power is something that you should keep in mind. So I derive a lot of my talk from this wonderful paper published by WHO very recently, and the whole world is struggling to get AI into loop. It's finding it difficult to get this powerful horse into ring. So this was a very nice paper which was written on ethics and governance. It's a huge paper. It's a brilliant but a huge paper. It was very beautifully summarized by Dr. Deepu and Dr. Avnish, and Amit here has summarized it. So I've taken a lot of material from there. So I'll just talk about it in detail here. So there are certain concerns that you should know. Now AI, is being used in radiology extensively, medical imaging extensively, oncology extensively, and diabetes. These are some of the areas in medical science where AI is being used very extensively. LLMs. Now what are LLMs? Dr. Amit has already explained to you, so I won't go into that. So you have large language models and small language models. These LLMs are basically using AI to give you precision medicine, enhance your clinical skills, enhance your diagnostic skills, and enhance your therapeutic skills. Problem is, you're seeing a patient today, right? So Dr. Somseth has seen a patient very nicely, and he used AI chatbot and said, fine, this guy's got type 2 diabetes and he's got multiple hypoglycemia, so cut down this insulin, do this, and your patient will be fine. He said, fantastic, I've got a taiyar cake in my hand, I just have to eat it. He stops using his clinical skills and clinical judgment, starts directly depending on AI to make all the decision makings. That is the fear that is happening, and that is not supposed to happen. You cannot replace, you yourself are replacing it with an AI. So using AI to make your treatment and diagnostic and therapeutic approaches, and it is your job to listen to that and use your brains and your clinical acumen to give the final output. But that is not happening. You are directly blindly listening to the AI and giving the therapy. And remember one thing, there is a nice pudding on the cake. The icing looks very good, the shoe looks very shiny, but the leather quality, So whatever ChatGPT and AI you're using, we're using LLMs. LLMs are large language models. That's a huge collection of data, right, on which the algorithms are working and giving you the output. So these LLMs are general LLMs. They've been picked up from a lot of database coming from Microsoft Azure, and that is being picked up from all the internet searches that you guys are doing. These LLMs are not designed on medical literature. These LLMs are designed as general LLMs. So how do you know that the output you're getting is a scientifically accurate output? No, you don't know. And that's what's happening, and that's why you're getting hallucinations. So there are certain concerns in the AI industry with a vision of AI that you should be aware of, and I will talk about it in detail here. You get inaccurate, incomplete, and false responses. You get biased data, which Dr. Devashish very nicely referred to. You get automation bias, which I just blame Dr. Swamsit for bypassing his patient's clinical acumen. Pardon me for doing that. I'm using you as a target to say that. Skills degradation, which we are seeing is happening in our medical residents today. They're getting degraded on their own. And something very important from the patient's point of view, you're using AI. Has your patient consented that I'm ready to be treated by an AI? None of us take any consent from our patient. We blindly use ChatGPT to treat our patients. Has the patient been made a partner in saying that I will be using ChatGPT to decide your neuropathy outputs, retinopathy outputs, and diet therapy outputs? That's important. So this is something which calls us hallucination. So Dr. Amit had already told you what are hallucinations. This is a medical term. So I give an input to ChatGPT, says that my 70-year-old patient who's a South Indian who's using masala dosas at least throughout the day is having persistent hypoglycemia and some episodes of hyperglycemia. Blood pressure is 150/90, blah, 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 HbA1c and all that. So tell me, is SGLT2 inhibitor the right therapy for this patient or not? And it says SGLT2 is absolutely not the right therapy, which is a wrong answer because that would actually help him quite a lot because he's got some diastolic failure, it's got some kind of CKD, early CKD, where SGLT2 is a drug of choice, but then for some reason AI feels it is not the right drug. So that is called hallucination. So you ask something and it gives you a wrong answer and you don't know that's a wrong answer. That's the whole part. You don't know it's a wrong answer. You think it's a right answer because a wonderful company has promoted this AI tool and pushed it into your clinic and you're using it. And there was a study which found that the hallucinations are as high as 27% of the time it gives you wrong answers. So I had also used ChatGPT to calculate eGFR and I got an eGFR of 1240 and that's not possible. So then what happens here is it's not ChatGPT who's to be blamed. So remember what I told you, you've got a wonderful Audi. If an Audi runs on the footpath, you can't blame the accelerator and the engine of the Audi. You push the accelerator at the wrong time. So the output that you're getting is because of something called as prompt engineering, which Amit had already told you. What kind of prompt you give is what kind of output you get. So it's called GIGO in computer parlance, garbage in, garbage out. You give garbage, you will get garbage. So you get the right prompt, you'll get the right answer. So it's very important that you learn how to handle ChatGPT. So after listening to us, don't open up ChatGPT and start pumping in your questions. You may not get the right answer. You have to learn how to ask the right question. So I always tell people AI is like a wonderful, intelligent kid on the block. You act smart with the kid, he'll act smart with you. You ask the right questions with the kid, he will get gold medal and show you. So you need to know how to prompt the ChatGPT or the AI tool, whether you're using Perplexity or using Gemini or using any kind of a tool that you want to use, or you're using Sora, which converts videos from your text messages, whatever you want to use. You need to give the right prompt. And this is for your knowledge that companies are employing engineers who are trained in prompt engineering and they're getting a pay package of 7 lakhs to 12 lakhs per month. Think about it if you want to leave your profession. It's a wonderful profession. You just know how to write the right prompt. So I always say that, you need to know how to impress your wife and life is good after that. So that's another thing that you need to know. So that is prompt engineering. Okay, data quality and bias. Now, whatever data you have, LLMs that you have, do you know how long they have been updated? So ChatGPT 3 to 3.5, which is your free version when you don't buy ChatGPT, the LLMs have been updated till April 2023, and naturally they have got no intentions of updating data any further. ChatGPT 4 was trained up to April 2024, but the last window which I have written is wrong. ChatGPT 4o, which stands for 4 Omni, has got the latest LLMs, which probably are just 1 or 2 months old. So I would encourage you people to pump in $20 every month like we all do and use ChatGPT 4o because your answers will be much better than using the free version of ChatGPT. Only thing is to get comfortable, don't buy the version, use the free version for a few days, but for genuine work, start using the paid version, which is where all the goodies lie. Otherwise, you may not get the right output. Now, automation bias, I already told you that there could be an automation bias. So what happens is if you're using ChatGPT or AI or Perplexity or Cosmo or Madhu or whatever tool you want to use, whatever tool you're using, if you keep depending on the tool to give you the entire management strategy, you will get automated. You will just look at the computer, it will tell you, give this prescription, give this drug, do this, do this, do this, and you'll blindly start doing it, forgetting that you are an MD and a DM, or whatever you are. Don't forget what you are, and don't forget your qualifications, and don't forget your residency days and the hard work that you have done to pick up those clinical skills. Don't get automated by a chat, by an AI tool, and go blindly behind it. So they can influence your moral judgment. And this is something very important, because the patients and the doctors can get dependent on an AI tool to tell you what is the right behavior in handling a patient and handling the scenario for their own future. And this is extremely important, and now we are realizing this, that a lot of residents are not taking the pain and the hard work to learn medical science. They are blindly using an AI tool to progress through their medical education and their residency, which is going to have a very bad impact on medical science tomorrow. So this is something important. Now, consent is a very important thing. I'll just take 2 minutes here, because I'm in the Mumbai High Court Committee. I'm also in the Medical Legal Committee, so I'm exposed to a lot of these things. Recently, if you remember, there was and I don't mind taking the names or not because it's now in public domain, there was a 25 lakh judgment against RG Stones for taking a consent of a patient, and the courts are very clear that when you sign, and this is something relevant to you, not relevant to the topic, but it might help you in your own practice. A lot of doctors and hospitals take a consent form which is pre-printed in any corporate hospital, make the patient sign, and they go for surgery or for procedure. It is totally legally invalid if there is a complaint against you in the Consumer Court or in the Supreme Court or High Court. A consent form cannot be a pre-printed form. It has to be designed, individualized to that patient. So even if you're doing a gallbladder surgery for the last 20 patients in the last 10 months, you cannot have the same consent form for all gallbladder patients. It has to be individualized to that patient, otherwise that consent form has no legal value if there is a complaint against it. Remember that the courts are very clear about it. So the consent form has to be individualized per procedure, per patient. Similarly, when you're using an AI tool, where is the informed consent? Do you ever bother to take a consent? I'm going to use an AI tool to make your diagnosis and therapy. Do you consent for it? Nobody does that. And in case your computers are not working, there's a crash down, then does the patient have a choice to give an informed consent in the absence of AI? These are questions which have been raised, and we do not have answers for that. And if you know, there's a beautiful hospital come up in China, which is a total AI hospital. But what about the consents of the patients are walking in over there? A big question to be kept in mind and to be understood here. Now, something called as patient-centered applications. So we're getting a lot of applications which are designed for patients' benefit, right? So there are certain chatbots and certain AI tools which will be meant for like a love guru, like a doctor in the pocket, something which will guide the patient as to what is to be done. So patient will listen to that. They will not listen to you. No, already it's happening. Patients think Google is a better doctor than you. So if Google says your headache is because of cancer, he runs behind an onco. So I get calls in my clinic, doctor, do you have an onco surgeon in your hospital? Why? No, I've got headache. I think I've got brain cancer. When is the doctor available? But you have got headache. How did you diagnose you've got brain cancer? No, Google told me, no? No, but then I'm supposed to diagnose. No, who cares for you? Google told me. Who are you to tell me? So we get such patients that my chest pain and my weakness and my sweating is because of a heart attack. But do you hear of a term called hypoglycemia? What is that and what the hell is that? There's nothing like hypoglycemia. I eat properly and I take my insulin minimum, But I've got this weakness and chest pain, it is heart attack. I want to see a cardiologist. I don't want to see you. You're just a diabetologist. Who are you? You're nobody for me. This information comes from Google, right? So tomorrow that patient is going to talk to AI. AI is 10 steps ahead of Google. So if I come in a Audi to the hospital and I flunk and I say, I'm the boss, Ben, I've got an Audi on which I'm driving. But if I drive in an Audi or a Maruti 800, how does it matter to my patient's therapy? My treatment doesn't change. So no, this is what is happening. When I see a patient in the corporate hospital, they feel he's a big doctor. When I see me in my nursing home, they feel it's a small doctor because he's sitting in the nursing home. But does my brain change within 5 kilometers here and there? So this is the reality. So this is what is going to happen tomorrow. Patients will be focusing on AI to tell their diagnosis and therapy, and they will start giving you wrong images and interpretations about your skills. Inaccurate outputs. So what happens is all these LLMs have been designed from certain researches which have not taken into account people who are paralyzed, people who cannot drive, people who are blind, people who come from a third world country or a developing country. A lot of research has been done in the developed country. So there is a lot of bias, and what kind of outputs are getting a totally biased output, but you feel it is right because US FDA is approved and it's coming from the stable of US country, right? So that is important. So this is what this slide is shown, that there is a lot of impact on a lot of people who have got disabilities and different genetic scenarios. Ethnic groups have not been accounted in that medical research paper, and that output has been taken up to decide what the LLM output will be given through the algorithm. So that is another point to be kept in mind. This is another important thing that technology fails when you don't want it to fail. Anyway. So what's happened? It's not moving. क्या हो गया? I know. I understand what is the problem. Oh, it's gone into the presenter mode.
You go out of presentation and again share.
Yeah, I realized that. No, it's gone. But it's not moving as per my slides. Okay, fine. Okay, privacy. Simple example, you are all using electronic health record systems. We all know that all the data is being sold to pharma companies. They know how to manipulate the data and they know which doctor to attack for what promotion. Everybody knows that. Whether they say yes or no, but everybody knows this is what is happening under the table. So all the data which is being generated by LLMs, by AI, how do you know that data will not be captured by a tech company and directed to certain patient groups to make more money? It's a big concern, and that concern cannot be answered because there is no law to control that. Very important. Now this is a very important slide. On one hand, when you're using an AI, you spend less time in doing clerical work. Today we are spending a lot of time filling up PHS, filling up consent form, doing this, spending a lot of time typing. My patients tell me, आपको अक्कल नहीं, आप computer देख के हमारा treatment देते because I'm busy typing and they say, doctors and many doctors will tell you that the patient is saying, वो तो computer देख के बताते हैं, हम उसमें उसकी क्या बड़ी बात है, computer जो बोलता है वही दवा लिख के देता है doctor. So, right, because we are busy typing and doing things. So tomorrow, all that time will be cut short, and there are enough apps available in the market where you just keep talking with the patient. So I said, hi Debashish, how are you? It was a wonderful trip we had in the morning, and what did you like, and how's the weather and all that. And all that is getting recorded in my EHS while all this is a beautiful case scenario which I don't want to show because I don't have the time. So patient comes and says, doc, I've got a little chest pain, I've got sugars for the last 10 years, my HbA1c has been fluctuating, my fasting is so-and-so, my post-lunch is so-and-so, my blood pressure is so-and-so, my triglycerides is so-and-so, and I've been taking this insulin, but I got hypos from this, and all that for 15 minutes is blabbering, and you're tuck, patient loses interest in you. So either you keep an educator who does all the clerical work for you and you talk with the patient, or let the AI do that. The AI will crystallize the whole thing into a histories, diagnosis, therapy, and give you guidelines what is to be done. While you can just put a hand on the shoulder and say, don't worry, I'm there and I'll take care of you, don't worry. And the lovely doctor, he listened to me and he put a hand on the shoulder and said, I'm there for you. Doctor, I'll pay your fees. How much should I pay you? So see, this is what AI does. But when you want to replace AI with yourself, you want to replace yourself with AI, then what happens is you say, start talking. अच्छा ठीक है क्या लिखा हाँ ठीक है चलो take this medicine go. Why? Because I'm not interested in listening to you. My assistant is doing it now. So the deterioration of doctor-patient relationship is also possible because of an AI, but that is created by you, not by the AI. So again, the same example of an Audi, a lovely car that you're having, but you decide to use the accelerator and the brake at the wrong time. Don't blame the company for it. Now there are two things you should know, what is called epistemic injustice and harmonistic injustice. What is epistemic injustice is when your simple thing, this is a technical term, when your judgment is being replaced by an AI judgment. So AI says there are wonderful apps which will say you pick up diabetic foot ulcer much early than you can see them visually. So you say this has got an early vasculopathy because the hairs have stopped growing and the skin has become little cool, but there is no ulcer. But AI says there is no diabetic foot. It's all normal, there is no ulcer, the skin is fine. But you say no. Even if the dorsalis pedis and posterior tibialis is palpable, but I am sure all the endos will agree with me if the skin is very cool, it is not warm, so it's an early sign of a vasculopathy, right? We keep that in mind as a peripheral vascular disease, but then you say, no, AI doesn't say that, so I think I'm right, I'm wrong, AI is right, there is no vasculopathy. You ignore the patient till he lands up with a gangrene. That is an example of epistemic injustice. Harmonistic injustice is when your patient will tell you, boss, I don't feel sensation in my leg, I feel there's a cotton wool sensation, and I know that this is an early neuropathy. My whole family has got diabetes, my doctor's told, very senior family practitioner told me he's got neuropathy, But AI says there's nothing like neuropathy in such situation. So that is called harmonistic injustice, where common sense and social senses are replaced by an AI understanding, and you believe AI more than your basic common sense. I'll skip this slide, we have already covered it. This I've already covered, I'll skip this, I've already covered this. This has been covered very beautifully by Dr. Debashish. It's playing a phenomenal role in drug development. Drug development which has taken 10 to 20, 30 years has come down to less than 6 months to 1 year. Fantastic development. Now I will talk on a different aspect of AI which is little beyond medical science, which is on labor and employment. And we all say that AI will not replace you, AI will not replace you. But the truth is a little different from that. Please understand that this is a Challenger report of May 2023 which shows very clearly that after the AI, the number of jobs have got cut down drastically, and the real criminals, the top criminals in the world are Facebook and Amazon. They have removed a lot of their employees because a lot of their work is being automated by AI. So as you can see very clearly, people have lost their jobs no matter what the companies say. This is a digital report that Meta is the name of the company behind Facebook. A lot of layoffs have occurred in Facebook. Recent data shows that AI job losses are rising, but numbers have not been given to the media to tell you the full story. And AI eliminated roughly around 4,000 jobs in the month of May this year itself. And Elon Musk is very clear about it. He's saying that it will happen in the future when AI will do such a thing that no humans will be required. You will just sit at the home and relax. All your work will be done by AI. And Otter AI is an app which we are using in Zoom meetings and all. While we are talking, it just transcribes whatever has been written totally and completely. Amit and me both are using it. And the CEO of Otter has predicted in the next few years, it will happen that you don't have to go to a conference to attend a meeting. Your avatar will do that. So bottom line is, I'm giving a talk here in Odisha. My clone would be giving a talk in probably Lucknow, and my third clone would be giving a talk in Kolkata. And all three talks will be running very beautifully and very intellectually, and you can't make out who's a real Alok Modi. And he said this is a practicality, and Shashi Tharoor's video, if you have seen, is a live example of that, where Shashi Tharoor talks with Shashi Tharoor, and you can't make out who's a real Shashi Tharoor. And there's a video very much there, and it is generated through AI. It's a very intellectually done AI work, and it is very successful. And if you people have exposure to Sora, by a text message, it generates such fantastic videos. So I want to say I want to be at the banks of the sea, wonderful sea with my wife today, and then my wife is not here, she's in Mumbai, but I want to walk around the sea at this time and get exposed a little, shower and feel very romantic. And Sora will generate, and I'll send that video to my wife saying, see, we enjoyed so much. But she's sitting in Mumbai. So that's possible with AI today. Cyber security is something, it's a huge topic, I won't take much. Your normal internet, your credit card scams are there. So you can imagine the amount of scams you can have with AI. Compliance with regulatory bodies. Now this is something very important, just watch out for my paper which I'm putting in the press very soon. There are a lot of regulatory bodies which are running with regulatory models. I'll just come to that a little later. Bottom line is, who dominates the AI ecosystem? Who decides how the AI will go? Who decides what will be the way the research will go? So all your medical researchers, there is a ethics committee, which is comprising of non-medical people. They can put a stab whenever they want for stopping your research going in the wrong direction. There are a lot of studies which say there is no ethics committee in an AI company. In fact, if they were, some of the companies have removed those committees totally and completely. They decide how the app will run, how it will function. Give you live examples. Sir has very clearly given some wonderful apps. There are so many apps which are floated by non-diabetologists in the world today, I don't want to name them, who have captured our business already. A lot of patients are going there and getting trained for their diabetes. They come to you when they need an amputation, or they come to you when they need a dialysis or an angio, because those companies can't do it. But the last 10 years they have destroyed your patient by talking gibberish and nonsense to them. And that's a reality today, you know that. So once that comes and AI-enabled apps are running in the market which are controlling patient output and behavior, you can imagine where we would go. LLMs consume money. There's nothing like a free lunch in the world. Everybody knows that. So we get all glamorized. But when we run these AIs, we need a lot of power. And where does the power come from? From your own planet. So to give you an example, a new LLM testing consumed around 3.4 gigahertz of power over 2 months, which could supply energy to 300 US households. Around 7 million liters of fresh water were used in training an LLM. So that is a kind of impact it is having on the ecosystem when you're running an AI industry. And that's one of the reasons why Indian government is not giving a lot of boost to AI, because we do not have the kind of resources to pump it into AI. And a lot of AI work is today being done through data clouds, which are funded by Microsoft and Amazon in the world. So what about the regulations and laws regarding AI? There are a lot of laws in Europe and US. I won't go into that. Just wait for my paper. They are covering it. What about India? India's got 0 laws. So far, no laws. And then in July, all the Indian penal system has changed. So Niti Aayog was the first one right from 2018 to 2021 and March 15, 2024, Niti Aayog introduced the MIT new advisory. So they have been working, they have been talking, they have been glorifying, they have been saying we have to do, but they have not come out with anything. There is no legal criminal activity yet. To give you a very basic example, if somebody writes a bad Google review against you today or tomorrow, and most of you, including me, have been subject to that mental violence, the law does not take any action. The moment you write something against a doctor in the US, you'll end up in a huge problem if you can't substantiate what you have written. In India, you use an AI tool which is misinterpreted, misguided, misused. Nothing can be done. What we have is a digital Personal Data Protection Act in 2023. It puts in a lot of breaches and regulatory bodies, but it is not very specific to AI. And the current thing is the IT Minister Ashwini Vaishnav has started working on it. And as a lead chair of the global partnership, India is a lead chair of Artificial Intelligence Global Partnership. And this meeting is held in 2024 where 29 member countries had participated, including the United Nations, AI practitioners, World United Forum, World Bank and all that. And they have come out with some guidelines and tools saying that we should do something. But when it has to be done and how it can be done is not yet in the legal framework yet. So that is where we stand legally, not very safe. So I think I've bored you guys enough. I've driven the Audi very responsibly so far. But then like Amit said, do join in if you're really interested and start becoming part of Doctors AI. We are responsible doctors, and the fundamental behind founding this Doctors AI is we do not want the tech companies to tell us how we should treat our patients. We want the tech companies to be told how to generate AI to treat our patient. We should be the human in the loop, and we should not having them as putting us second in the tech in the loop. So that's the purpose behind Doctors AI. Do join in. I do a lot of work which is non-AI work also in my other group called as Tech Doc Updates by Dr. Alok Pavi. Can join that also. I handle a lot of mobile and Windows and laptop technology over there. Helps a lot of people. So both the groups are very active. If you're interested, you can join in. And before I conclude, and I have said thanks, and I would like to give a lot of thanks and my respectful regards for welcoming me to this wonderful city. It's always an honor and a pleasure and a very humbling experience to come here. I would like to thank Panda sir, especially in the organizing committee, for this wonderful opportunity on this wonderful day and wonderful time. Thank you very much for listening to me.
Thank you, sir. It is a wonderful session, wonderful workshop. It starts with introduction of AI by Dr. Amit, followed by Dr. Devasis, its organizing and its use, followed by Dr. Mangaras, its use in diabetic, and after that a word of caution from Dr. Modi. So now the forum is open for discussion. Any queries from the audience? I request all.
Can I request all the faculty to come on the dais?
Any questions from the audience?
May not be questions. You can have your discussion. You can just share your experiences.
I think that's
You can pass your comments.
I presume that most of us would be here today, would be listening to an AI session, probably for the first time. So it will be a lot to absorb. So somebody wants to ask the question at the back.
Yes.
You want to ask something, please? No. Yeah. So I presume that, I presume that most of us would be listening to an AI session for the first time. So there's a lot to absorb. But as we always say in most of our workshops, that we've got to start somewhere. And you start with being curious. That is most important. And the second most important part is you start asking that question that how is this happening? How is this algorithm working? I commonly say that it's no longer like a Star Trek sci-fi movie. You don't get fascinated and ask that, wow, this is happening. You need to ask, how is this happening? So from that wow factor, we need to get into that how factor. And we need to ask that question that why is this algorithm being used? Is this explainable AI? Is this transparent AI? What Dr. Modi just showed. Is it being used for the right use case? Has it been validated? Has it been evaluated? For example, what we tried to do with Madhu was we tried to validate it. Because anybody can use a user interface, line it up with a large language model, and make it a chatbot. But how do we know as a clinician that this chatbot is going to give the right use case responses to the patient? It is only when we as clinicians, as experts, are going to validate it and evaluate it. So I think we are all evolving in this era, and as clinicians, as doctors, as I always say that we have all been growing up with reasoning and evidences. We need to set those standards, and we need to get ourselves aligned and completely thorough with the basics of AI. And once we start getting adapted to it, we will start learning and we will start adopting AI into our practice.
Yeah, no doubt this is the beginning of a very great thing, because tomorrow, next century or next decade is the decade of artificial intelligence. But we should not forget our basics. Everything stands upon the basic. I think Dr. Modi will elaborate. Yeah. Your opinion on today's scenario on particularly deep learning.
I always feel a stethoscope is something that we always need. We used to hear with our ears once upon a time, then we needed a stetho to become better. Today we need an AI to become better. The word technology improves. Today tell me one thing, how many of you can say you can live without a smartphone? Nobody can live. Do you keep a normal phone? No, you need a smartphone. Today a smartphone has 8 GB and 12 GB of RAM and a processor which is equal to a laptop. 6 years back, people would not even believe it's possible. So 5 years from now, probably we'll meet here and we will be talking through AI. We will not be talking without AI. So it's very much a reality. It's not that it is impossible, but all we are trying to do is remove that early fear that you have. There's a little phobia for an unknown people don't want to do. So please get into it. Phobias that I've seen people are, it's too hard, it's very difficult. It is not hard, it is not difficult. It is for you. We have got trained in AI on our own. Amit and me have cleared the American Board of AI exams. We have got certified by 2 US boards.
Yeah, now it is included in the curriculum, PG learning, AI learning in the PG curriculum of MD medicine by NMC.
Yes.
Yeah.
There was a time when people would not do DM in gastro, anesthetists would just do MD anesthesia. Today they are sub-specializing in critical care, they are getting qualified. In our time it was not there. Tomorrow will be a time when you will have your juniors getting certified in AI and you will not be certified. So it doesn't matter, you can't go back to college and you can't go back 20 years. So start getting your hands dirty, as they say in curriculum, and start learning and start being happy and start realizing a very nice adage is there. Learn, unlearn and relearn. So if you don't know, unlearn and relearn and get your hands dirty and start playing with AI. It's beautiful, trust me, it's very nice. The moment you know that you have to be non-judgmental and you have to be responsible, you will not do mistakes with AI. It's a wonderful tool. So attend more seminars, conferences and come out and talk. And something in a mini meeting I tell you, people feel, how can I ask this question in public? There are 20 people who have the same question as you. So get comfortable, start interacting, start joining various groups like our groups, start interacting, start playing and start coming and start talking and sharing your experiences. That's the best way and it will become a part of your life like your own family member and you may not be able to live without it, but the idea is it adds value to your life and to your patient's life. There's a whole purpose. It should not decrease the value of your life and your patient's life. It should add value in a positive and in an authentic manner. This is the whole idea.
Yeah, thank you, sir. Thank you very much. Dr. Debashish Das is joined in a very good company which is manufacturing all those devices. I think he will enlighten us. Thank you.
No, I have this. Okay. I just wanted to add, I work with the Ministry of Science and Technology, Government of India. I sit on as a technical expert for startups, especially for medtech. So we encourage, Government of India gives 50 lakhs of grant just from idea to POC. Any of you as an individual, if you have an idea, you have some work, you can always reach out to me through BIRAC. You can apply to the ministry, you get 50 lakhs from idea to POC. It has to medtech. A lot of engineers from Odisha, a lot of physicians also I know in Odisha. One of them, I know a couple of them from KIMS, some of them from AIMS Bhubaneswar have already got the grant. From 50 lakhs, it goes to up to 2 crores.
It is from Ministry of
Ministry of Science and Technology.
Yeah, DBT.
DBT.
Yeah.
And BIRAC is the body which, and I sit on the panel for funding. So I encourage if you have, but again, medtech means your input is clinician. So you have to collaborate with an engineer. Okay? So the clinical problem or the need has to be identified by you. First, you identify the problem, validate it, and you think you have an idea to solve that, collaborate with an engineer and make a project. If you are working on AI/ML, we have experts from physicians like Dr. Modi, Amit is there. I am there to support you the whole process. But I encourage all of you, nowadays we have already granted some 1 lakh startups. Out of that, thousands already marketed. And the primary motive of this project is not research. You have to come up with a product which can be marketable. That is the primary requirement. That is this product business viable. Okay, so if you have idea, talk to me, talk to engineers, form a team and apply for. I see 90% of them are engineers from IITs, NII, this and that. Doctors very rare. But the clinical problem you can identify, they cannot identify. They are sitting in the lab or they are sitting somewhere else.
Actually, from our undergraduate or postgraduate teaching, we need one skill lab type of things to learn AI better. So in this skill lab, better we have to include this curriculum. So that is the point I am highlighting.
So I just wanted to highlight, so now Government of India has said every engineering college to have a startup incubator. If you go to any engineering college, KITS has, some has, even AIMS New Delhi has. So now every medical college should also have a startup incubator. And it should be independent body directly working under the director, which will support startups.
Yeah, I just want to add on point to this context is that we've recently had conversations with engineering colleges where we will be actually planning hackathons, bringing in medical students and engineering students and giving them a project to work on and sort of build something and present. I think that is going to be probably a start, and we will be taking some initiative.
I think
IIT Kharagpur is doing, we are already in talks with them to
One comment I wanted to. And the live example to encourage you is Madhu, which Amit has is his brainchild, and we all have worked for it. So that's a wonderful thing. It works on a WhatsApp through API. So you ask Madhu any question, it will tell you the answers. I actually twisted it very badly when I was validating it. I said my doctor has given me SGLT2, so that causes urinary infection. I should take the doctor to court. It took me through as a patient. I posed it, it walked me through so beautifully that I got convinced and I thought I should take SGLT2, but I was not willing to take. So this is a kind of work which we have done. He's developed it with an engineer. A lot of efforts he's taken on his own to develop it. It's got validated, it's got published, it's a beautiful tool. So if we can do that, why can't you do it? Come out and do it. It's something the country needs to move forward, and we will move forward. So just thought I'll share this with you because Amit has taken a lot of pain to develop it. So many things are there which we can develop. So get out of the 4B and become serious and do it. I mean, there's nothing bad about it. It's very good.
Dr. Sansida.
So I think we had heard few excellent talks regarding at least introduction and what is the way ahead for AI in healthcare. So just I will say few things. If you remember, we have to deal with AI. There is no escaping from it. But as physicians, what I will concur with what Dr. Alok said, you need to understand AI cannot beat you in every domain, apart from repetition and consistency. You just have to believe and tell your patients and differentiate what science from pseudoscience. An app or AI tool may look wonderful in Facebook, Instagram and Google, but look whether that is backed by science. There is published data to back its efficacy, what it intends to do. Then there is a difference between a common man and a physician. You cannot blame AI through and through. You have to choose apps, tools which have data to say that it actually works in clinical care settings. You need to put your efforts to develop those kind of tools or data. Just merely saying AI can do everything, it's also false. And if you tell AI cannot do anything better than me, that again you are in problem. Next thing is just a simple, if you want to do any study, right from undergraduate, postgraduate to super specialty, then you take help of conventional statistical tools to tell you that. Then as you move up the ladder, you take regression, logistic regression, anything. Then comes the course of machine learning and algorithm. These tools can give you data, a more refreshed view to look at it. And mind me, you see in the next couple of decades, all big journals with good impact factors are going to publish data which have utilized AI or ML in at least studying the data and publishing it. They are not going to publish your data if you have done a regression or a P or a T test. They are not going to look after it. So data should be good, clean, and you should use tools just like AI for validating that. I think those kind of things are quite real. There is something not very unreal and unrealistic. So that things will be refined as we go and progress with the development of AI.
Thank you very much. Thank you all the speakers, Dr. Alok Modi, Dr. Amit Day, Dr. Devasis Das, and Dr. Swayam Sid. And my thanks to all my co-chairmen, Dr. Satyankar and Dr. Dhiraj. So I think we are ending this session. This is a wonderful session. Thanks to all wonderful participants. Thank you very much. So the session ends now.
Thank you.
Sir, एक मेरे मोबाइल पे ले लेंगे. 1 second. I'll share it with everyone. Just stick to it. Sir,
ग्रुप में डाल
अच्छा अच्छा हाँ मैं ग्रुप में
workshop.
अच्छा सर के साथ भी एक ले लो छोटे में है बड़े में है
डॉक्टर्स मैरिज
बस
दर्शन हो गया दर्शन
सब सब हो गया बहुत अच्छा दर्शन है थैंक्स फॉर देवाशीष बहुत अच्छा था
अभी
वेरी नाइस
सो रहे थे जगन्नाथ तो सो रहे थे
So, for 10 minutes tea break. After that, we'll start. Next
आप आने
session.
वाले थे उठ के
ତାପରେ ମୋର ଏବେ ଅଛି ପ୍ରେଜେଣ୍ଟେସନ ଲୋଡେଡ୍ ଅଛି ଏ ପଏଣ୍ଟରଟା ମୋର ସିଏମଇ ଫାଷ୍ଟ ଏଇଟାକୁ କନେକ୍ଟ କରିଦେବେ ସେ ଲାଇଭକୁ ପଏଣ୍ଟର
We'll having a short tea break outside the hall. Then we'll join for the pre-conference CME.
Simple white type of
ये करेक्शन हो जाते हैं
फॉर्मेट जो होगा ना किधर टाइमर चलो ठीक है जाने दो वैसे सिर्फ मिनट्स का भी होता है आप वही ले लो नीचे ले लो ऊपर करो
White वाला लाइटिंग ऐसे नहीं है सही ना हम कैमरा खड़ा करो
ठीक है पुश कर दो दोनों जगह पुश करो
अरे मुझे
यहाँ पर भी रिप्ले हो रहा है ना
बोलो भाई
म्यूजिक डाल दो और म्यूट कर लो आपका साउंड कुछ और ना जाए उसके अलावा
Good evening, dear friends. We will be starting a new session. We have three topics in this session. One is pathophysiology of type 2 diabetes and tropical infections in diabetes and vaccination in diabetes. So the first topic is pathophysiology of type 2 diabetes, unveiling the enigma. As all of you know that diabetes is growing at a very, very exponential rate, causing huge morbidity and mortality in the society and world over. And keeping pace with the rise in epidemic, rise in the diabetes epidemic, our knowledge and understanding of the pathophysiology of diabetes has also developed very fast. We have moved from the simplistic model of insulin deficiency and insulin resistance to ominous octet, dirty dozen, sweetening 16, involving various other players like catecholamines, vitamin D, RAS system, then testosterone deficiency, melatonin, and various other factors involved in the pathogenesis of the diabetes. And as we delve further into the pathogenesis and understand the pathogenesis of diabetes, we will be equipped with more and more of therapeutic modalities to tackle the epidemic diabetes. So with this brief introduction, I will now request Dr. Professor Mahapatra to speak. And before that, I will just introduce to him, probably all of you must be knowing Professor Mahapatra. He is the currently posted as Dean and Principal, Jajpur Medical College. Prior to that, he was Professor SCB Medical College. As I know, we are contemporaries at Barampur Medical College during 1980s. As I know, he was an excellent student, brilliant track record of academic activities, and excellent academic and professional credentials to his credit. He is the Vice President of ODISHA Hematology Association. He is life member of IMA, IHSBT, IAPM, publication. He has huge publication, many publications, 97 national publications and 27 international publications in peer-reviewed journals. He has been awarded gold medal in MBBS, silver medal in FCGP exam, and he has been awarded best research paper awards in state and national conferences of ISHBT, the Indian Society of Hematology and Blood Transfusion, and Indian Association of Pathology and Microbiology. He had been adjudged as the Man of the Year award from North Carolina, USA. So we have a excellent speaker with huge track records of academic activities. With this, I will call upon Professor Mahapatra to deliberate on this topic, an interesting topic.
Dear chairpersons and dear colleagues, my talk today will be pathophysiology of type 2 DM, unveiling the enigma. It's actually an ocean, so I will be running quickly through these slides as far as possible to keep my talk within time. So this we know it's a metabolic disorder due to defective insulin secretion by the beta cells and insulin resistance, two primary mechanisms. Risk factors, genetic, metabolic, environmental like obesity. Ethnicity has a huge role in the clinical appearance of type 2 DM. Japanese, Hispanics, Native American, Asian, blacks and Indians of late have been studied in detail. Risk factors, we know they are modifiable, non-modifiable. Modifiable, obesity, low physical activity, unhealthy diet, ethnicity, family history, genetic predisposition are non-modifiable. Then if you see there are few things, this laser is not able to connect here, but what is important is mitochondrial dysfunction, gut dysbiosis. Diabetes is a chronic inflammatory state throughout the life, and there is a generation of reaction, the ROS, which damages the whole system, multiple organ, and genetics is also, that also decides insulin secretion and insulin action. And if you see down below, there are several other mechanisms wherein you find lot of inflammatory cytokines. So hence I say diabetes is a chronic inflammatory state, and all the organ dysfunctions are related to this chronic inflammatory state finally. Now, if you see the causes, mostly as you can see, intrauterine development environment starting from the fetus in the mother's womb. They can be predisposed to diabetes, which I'll show you another slide. Dietary excess, inactivity leading to obesity, mitochondrial dysfunction, either age related or as such due to the changed metabolomics, and stress all lead to an inflammatory state which leads to insulin resistance. And genetics, epigenetics and gut biome, the gut dysbiosis has become upfront now as a very important factor in regulating the blood sugar levels. So that decreases insulin secretion, sensing and beta cell survival growth, and that leads to type 2. So these are the same things, has been picturized in a different way. The risk factors modifiable and non-modifiable. Now coming to the one beautiful segment of type 2 DM, ethnicity. Now of late if you see, then the genetics of type 2 DM, if you see from 1993 to 2012, there is an exponential rise in the study of the candidate genes all over the world to link them to a particular disease called as type 2 DM. If you see from linkage analysis to the human genome, the HapMap project, the genome-wide association studies and the whole genome sequencing, you can see there is a, till 2012 this map, you can see there is a wide study of hundreds of candidate genes trying to link to type 2 DM. And these populations are mostly very much predisposed. Mexicans, Cubans, South Asians, as we know, they are 25%, 21%, they are very high type 2 DM in these populations. So ethnicity is definitely related to the emergence of type 2 DM. They are predisposed. The genetic constitution of these ethnic populations predispose them as the non-modifiable genetic factor to type 2 DM. Now if you can see from 2001 to 2014, there is an expansion of candidate genes that has been identified by WGS method and NGS, which have been linked to type 2 DM. Hundreds of genes, but there is no inconsistency, there is no consistency, inconsistent link to the type 2 DM, except for few genes like IRS1, IRS2, HNF, SCF7. There are 4, 5, 10 genes which has been definitely linked in all, universally all ethnic populations to type 2 DM. So these are the things, these are the genes. Obesity, there are genes identified in the blood. Triglyceride clearance, genes are identified. Insulin resistance, there is a set of genes which have been identified. Skeletal muscle insulin resistance, there is another set of genes. Liver gluconeogenesis, there are set of genes. Adipose tissue, adipokine and fat storage, there are set of genes. So it is a multiple genes which affect the multiple organs. Now HLA we know connected, and there are certain ATP binding and PARP which are also gene mutations are possible which can cause type 2 DM. Now if you see insulin gene mutations, we have several insulin gene mutations at different level. At insulin gene, glycogen synthase gene and beta-3 adrenergic receptor gene, you can have multiple genes involved. Mitochondrial diabetes, we know this is a maternal inherited diabetes, and there is deafness due to mitochondrial DNA mutations. Mitochondrial DNA defects and mutations of various sites and loci can be found. One thing is these mitochondrial DNA mutations are always 100% penetrance as compared to the nuclear DNA. Hearing impairment is there, MELAS, and mitochondrial DNA mutation, that is, there is disruption of the ADP-ATP ratio, and usually seen in third and fourth decade. Aging has an important role. A little bit about mitochondrial DNA mutations. They are more predisposed to the ROS, as I will be telling you, than the nuclear DNA, and more susceptible to DNA mutations than the nuclear DNA. Now epigenetics and type 2 DM. This is interesting because epigenetics is something where there is acetylation, phosphorylation and methylation of the DNA without changing the reading frame of the DNA. That is the nucleic acid residue change. There is no change. The environmental factors have an enormous role in producing epigenetic changes in the genes, and which thereby cause type 2 DM. And this starts from the intrauterine life itself. If there is undernutrition of the mother, it leads to undernutrition of the in utero fetus, and later on the fetus is exposed to or predisposed to develop type 2 DM. This is just because of epigenetic change. There is no change in the DNA sequence. So environmental factors are there. Obesity induces epigenetic dysregulation. Obesity is a very important factor. Glucolipotoxicity increases DNA methylation. You know, in type 2 DM, glucolipotoxicity is an important part. And epigenetic modifications are reversible in nature. This is one beauty. If you change the lifestyle, the epigenetic changes that have occurred can be reversed. But epigenetic changes, if lifestyle modification factors are not done, they are heritable, and they are heritable to 2 to 3 generations onward. So, the father not doing lifestyle modification, the son will get affected. If the father reverses the epigenetic changes, the son will be spared. So, something like that. And gut microbiota, as I said, because gut dysbiosis has a very important role in type 2 DM. Environment, that's what. Environment can produce epigenetic changes which can have transcriptional regulation and diabetic phenotype. Genetics also, the DNA sequence variations can give rise to diabetic phenotype. So same thing, epigenetics, genetics and environment all together working, and finally leading to epigenetics can have type 2, genesis of type 2 DM. And mechanism of this epigenetic changes are two. One is first generation mechanism, second generation mechanism. And remember one thing, whether there is a acetylation or methylation, the genes can express in two different ways. There can be, one is gene silencing, the gene can be silenced, and two is there is overexpression of some genes. Both the things, one is very negative and one is very positive. Both the things can happen when there is epigenetic changes. Now this is beta islet of Langerhans, where beta cells can have a number of genes which can undergo epigenetic changes, and can they lead to beta cell apoptosis, beta cell transdifferentiation and beta cell failure finally, which I will be showing you another slide also. So environmental factors, epigenetic changes can have multiple effects on the pancreatic beta cells, liver, muscle, adipose, vascular, endothelial cells, immune cells and all organ cells, and gametes. Until gametes you can have, and there is, once the gamete is involved, there is epigenetic inheritance in the germline, changes will be there. Now environmental factors, role of diet, we are all very clear about this. Now these days carbohydrate, fat and free fatty acids is taken to be a poison almost now. I will show you another slide of that. So all these things produce, finally, as I said, diabetes is a chronic inflammatory state. Inflammation, oxidative stress, which leads to mitochondrial dysfunction and endoplasmic reticulum stress, NADPH oxidase, superoxide. That pathway is very clear. Most of you know this pathway, and finally it leads to type 2 DM. Physical inactivity or exercise, it's a low-grade chronic systemic inflammation, we know. Pro-inflammatory molecules like IL-6, CRP, TNF-alpha, IL-1 lead to metabolic inflammation. If you don't do physical exercise, your body will be under a severe metabolically inflamed state. Interleukin-1 produces inhibition of beta cell function, activation of NF-κB. Obesity, there is immune cell infiltration, as I will be showing you. Obesity is the adipose tissue which is constantly chronically inflamed. Exercise reverses all these things. One more thing you will be enlightened to know that exercise can have genetic modifications which are reversible, and that will be there in the next slide. So you see, physical activity, inactivity, if you, genetic modulations, this is very new thing. Once you do exercise, the genes will be modified. Epigenetic changes will be reversible if there is physical activity. Sedentary lifestyle will give rise to genetic modulations that will predispose the individual to develop type 2 DM. Then there is increased beta cell insufficiency, dyslipidemia and obesity, lack of physical inactivity, oxidative changes, oxidative damage, mitochondrial dysfunction, inflammation, sex steroids, both male and female, both can fluctuate and which will predispose to the type 2 DM, decreased capillarization in the skeletal muscles, and increased ceramide synthesis, that is the cell wall proteins or lipids and proteins, that will give rise to the type 2 DM. And finally insulin resistance. All these axes leads finally to insulin resistance. And if there is physical activity and exercise, everything is reversed. Role of stress, everybody is under stress. Everybody is under stress. We say 10% diabetics, we say 100% are under stress. Am I wrong? Am I wrong? 100% of world is under stress. So if you don't have anything to develop type 2 DM, you will develop type 2 DM because of one factor is stress. Everybody has, nobody can deny this. If he is denying, he is telling a lie. So chronic psychological stress or depression, whatever, produces hypothalamic pituitary adrenal axis activation, which gives rise to increased cortisol, autonomic nervous system activation, which gives rise to increase in epinephrine and norepinephrine, inflammation also, IL-6 and CRP levels will be raised in stress. This leads to increased intra-abdominal fat, the waist circumference is increased, insulin resistance will be there, endothelial dysfunction will be there, and this all will lead to type 2 DM. So this is also reversible. Stress can be taken care of without any drugs. You know the methods. Now coming to the pandemic of obesity in the world, and more so in the Indians. The abdominal, the central obesity. So in obesity, adiponectin fall, increased leptin and other factors, as I have shown you here, NEFA is increased, and inflammatory cytokines will be more, and that will lead to beta cell dysfunction and insulin resistance. This is a low grade inflammation. Obesity is a low grade inflammation all the time. And increased ROS, dyslipidemia, beta cell stress, finally leading to insulin resistance and leptin resistance, and this is reversible. Body mass index we know more than 430. If you see these two, this is healthy adipose tissue, that is pathologic adipose tissue, wherein we will find different kind of inflammatory cells. In the pathologic cells we find T1 and M1 macrophages along with NK T cells and T cells, CD8 lymphocytes. All these inflammatory cells in the obese tissue will release an array of cytokines and will produce chronic low-grade inflammation, which will give rise to insulin resistance. Same thing here, I have given the molecular mechanisms by which these cytokines are increased in adipose tissue. This is the inflammation hypothesis. Adipose tissue central obesity is inflamed. This is the primary cause of insulin resistance. It can be reversed. So same thing, obesity and the different healthy expansion of adipocytes versus vis-a-vis the unhealthy expansion of adipocytes. If there is unhealthy, there is decreased adipogenesis, increased cell hypertrophy, decreased insulin sensitivity. There is a low-grade inflammation because there will be macrophage, CD8 lymphocytes, macrophage 1, CD8 lymphocytes will be, and TH1, T helper 1 inflammation will be there. That leads finally to lipotoxicity. So same thing, finally all these whatever obesity causes in different organ systems finally lead to insulin resistance, and that is a great problem for type 2 DM. Aging and cellular senescence, you cannot stop. Every minute we are aging. People calculate age by day. actually the cells and DNA calculate the age by minutes. The telomere, attrition of telomere occurs by minute to minute. Life is fixed. So senescence has a very important role in genesis of type 2 DM. Now decrease in lean body mass, increase in visual fat leads to insulin resistance, insulin sensitivity, decrease insulin sensitivity, decrease beta cell mass. The beta cell also islets, they will also be undergoing senescence, obviously as far as other cells are concerned. Mitochondrial function, mitochondrial will also age, everything ages. The DNA ages, the cells age, the organs age, the human age. So everything is senescence. Senescence itself it generates large number of inflammatory cytokines. Okay? So chronic inflammation. So hyperglycemia, So metabolic dysfunction and lipidemias which are associated here, which inhibits insulin stimulated glucose, decrease beta cell proliferation and increase apoptosis. Beta cells die because of other mechanisms also I will be telling you. The beta cell dynamics also is very critical in type 2 DM. There will be sarcopenia, irreversible growth arrest. And what is important factor that is produced in senescence is SASP1, we call sterile secretory phenotype 1. That's a very important, so hence the application of senolytics in type 2 DM therapy. Then hyperglycemia itself causes large amount of inflammatory release, and senescence induced immune dysfunction. The immunological system also undergoes senescence. Everything undergoes senescence. So all our defense mechanisms are aging every minute. That predispose the individual to develop metabolic diseases, leave aside type 2 DM, other metabolic diseases also. So therapeutic targeting of SASP is a modality of treatment. So same thing, as I said, extrinsic stress, telomere erosion with aging. Here in this photo I am trying to connect P53 and P21 to the genesis of insulin resistance and inflammation along with aging. So P53 and P21, NFKB. So the senolytics and SASP inhibitors role in senescence induced damage to prevent that. Now, diabetes is a chronic inflammation. So macrophage, as I said, macrophage adipose tissue, pathologic adipose tissue is macrophage 1, Th1, NK. So that will release cytokines of various types, and that will lead to insulin resistance, endocrine dysfunction, and impaired glucose disposal and beta cell dysfunction. So if you see this DAMs, ceramides, pre-cholesterol, ROS, LDL, hypoxia, tissue necrosis, all these lead to NLRP3 inflammation assembly. That acts through caspase activation, producing interleukin 1 beta and interleukin 18. That produces insulin resistance and organ dysfunction. So diabetes, as I said, I am trying to prove that it's a chronic inflammatory state steadily going on, and which adds fuel to the fire. So the same thing, the inflammatory pathway leading to IL-1 beta. Then insulin resistance. Insulin resistance is insulin deficient conditions where there can be an action of insulin regulators like growth hormone, IGF, glucagon, glucocorticoids, etc. So this is seen in skeletal muscle, liver, adipose tissue. Every organ can show insulin resistance, and adipose tissue IR and skeletal muscle IR, liver IR. I have lot of everywhere if you see, it's all induced by inflammatory cytokines, and I have shown you where cytokines are generated. So defective glucose transport signaling, obesity is the most important cause of insulin resistance. Main components of IR, if you see, there is a dysglycemia, dyslipidemia, obesity, hypertension, hyperinsulinemia, and insulin resistance variants we have classified into type A and type B. So same insulin resistance at the level of GLUT4 receptor, and same mechanism of insulin resistance with mitochondrial dysfunction leading to insulin resistance in white adipose tissue, skeletal muscle and liver. And here lifestyle factors can same, as I said, pro-inflammatory adipocyte hypertrophy, finally leading to beta cell failure and development of type 2 DM. So insulin resistance can be hepatic, muscle and lipid and adipose tissue, all everywhere there can be resistance. So glucotoxicity, lipotoxicity, inflammation, three primary arms to produce insulin resistance and endothelial dysfunction together with insulin resistance. So free fatty acids, as I said, is the poison which leads to a large amount of metabolomic changes, which leads to finally either increase in inflammation, insulin resistance, endoplasmic reticulum stress, and apoptosis of the beta cells also. GLUT4 and IR, at that level also they can work. Now coming to beta cell dysfunction, as I said, beta cell dysfunction is decrease in the beta cell mass less than 65%, which can occur due to hyperglycemia, hyperlipidemia, inflammatory cytokines, endoplasmic reticulum stress, all can induce beta cell dysfunction. Beta cell apoptosis. When the beta cells apoptosis occurs, first of all the alpha cells and other delta cells, they try to recapitulate that. Either there is a transdifferentiation or there is a dedifferentiation. Then it reverses. The insulin secreting cells will start, beta cells will start secreting glucagon. That reversal phenomenon can also occur. But first is compensation. Stem cells will come out, try to compensate the loss of the beta cells. Finally, when they fail, and the alpha cells and other delta cells also will try to transdifferentiate into beta cells, try to make up the beta cell loss, finally fails, and there is de-differentiation of beta cells into alpha cells, then secreting glucagon instead of insulin. That's a dangerous situation. Change on. Change on his slide. So beta cell apoptosis is complete death of the beta cells, which can occur due to glucotoxicity, lipotoxicity, and inflammatory cytokines. All can induce apoptotic genes, pro-apoptotic. Now this is what I was telling you, beta cell differentiation and transdifferentiation and dedifferentiation. So similar thing, the healthy beta cell can be stressed beta cell and there will be beta cell failure, dedifferentiation, and there can be apoptosis and there can be transdifferentiation. Then mitochondrial dysfunction, as I said, can occur in mitochondria in oxidative stress, ROS, nutrient overload, cellular stress, and all these can give rise to mitochondrial dysfunction, and which will lead to the metabolic dysfunction. Mitochondria, if you see, mitochondria, there are two processes. One is a fission and one is a fusion. In diabetes type 2 DM, there is lot of fission. They break into smaller mitochondria which are less capable of carrying out the oxidative phosphorylation and genesis of ATP. Fusion is less and fission is more. Fission overtakes fusion. So genetic factors, environmental factors can give rise to mitochondrial dysfunction, which can lead to beta cell dysfunction and insulin resistance. All can lead to type 2 DM. So you can see on that side mitochondrial fusion and fission. Fission is more. I'm completing that. Quickly running through that. So same mitochondrial dysfunction. There is paucity of time, so I have to run through these slides. And mitochondrial dysfunction, there is defective electron transport chain and there is mitochondrial fission more than mitochondrial fusion, which leads to finally to insulin resistance. Gut dysbiosis. In gut dysbiosis, you can see here the normal healthy epithelium wherein you find the bacteria and the mucin along with intact epithelial cells. Whereas in diabetes, you will find there is a change in the microbial flora. There is less of mucin and there is tight junctions are loose now. The lipopolysaccharide of the bacteria getting deeper into the systemic circulation producing endotoxemia, metabolic endotoxemia, and that leads to inflammatory response and that leads to type 2 DM. So this is the same thing, the schematic of the gut dysbiosis has the role of pre symbiotics and postbiotics in producing ebiosis in diabetes. Maternal type 2 DM, as I have already said you, that if there is undernutrition of the child inside the mother's uterus, which leads to epigenetic changes in the fetus, and the same fetus in the adult life is predisposed to develop type 2 DM. So this is the mechanism. There is no time, so I can't go through the details. Same mechanism. So conclusion. So finally concluding, rapid advancements in modern medical research through the spectrum from clinical to molecular levels have played an instrumental role in unveiling the mysteries of this complex, poorly understood enigmatic disease, which will go a long way in the development of novel therapeutic strategies and protocols to prevent and treat this global pandemic disease of high morbidity and mortality. Finally, precision medicine. Targeted therapy, precision medicine. So whatever pathophysiology of type 2 DM I have said, it needs multi-modality of treatment and approach. And finally, non-modifiable factors, genetics, modifiable factors if they can take control of, including gut biosis, dysbiosis, that is important, along with inflammatory conditions, oxidative stress, bringing down the oxidative stress, taking care of the diet. As I said, physical activity is linked to even genetic modulations, so that can be reversed. Epigenetic changes which leads to diabetes can be reversible. If not reversed, they will be going for 2 to 3 generations of inheritance and will predispose the offsprings of for 2 to 3 generations to develop type 2 DM. All these modifiable factors are possibly can be treated and modifiable, but a strict regimen has to be maintained. And non-modifiable genetic factors, we are not very sure, but I am hopeful that in future 5-10 years ahead, we will be able to find out 1 or 2 or 5 candidate genes, very specific genes which control the complete dynamics or metabolomics of diabetes, and we can go for a precision medicine or a gene therapy to even modify that. So all this, it needs a multiple approach in complete forum to treat or take care of a patient of type 2 DM. Thank you so much for a patient listening. I would have loved to go through all the molecular mechanisms at the molecular level, but there was paucity of time. Anybody wants my presentation can take a copy of that and go through the molecular mechanisms of the pathobiology or pathophysiology of type 2 DM. Thank you so much.
Thank you, Professor Mahapatra, for an excellent exposition on the primary pathogenetic mechanisms involved in diabetes. As we understand, diabetes and inflammation are closely linked to each other. Inflammation can lead to diabetes, and diabetes can also lead to an pro-inflammatory state. So, thank you once again.
One or two more quick questions if anybody has to ask, and I can take 1 or 2 quick questions. Okay, thank you so much.
Thank you.
Good evening, all of you. So the next topic is tropical infection in diabetes. We all know that diabetics are more prone for infections and more prone for complicated infections. So not only we should identify the infection early, we should treat aggressively. So we have Dr. Anupam De, Professor Head, Department of Medicine, AIMS Bhubaneswar. He is recipient of the 27th Devang Mehta National Education Award, and he is awarded with fellowships of American College of Physicians and Indian College of Physicians. So over to you, Dr. Anupam.
Thank you, chairpersons, for the kind introduction. I will thank the organizers for giving me this opportunity today to speak in RSSDI ODISHA. So my topic for today is tropical infection and diabetes, a very pertinent topic because this is all that we come across so common. So when we say tropical countries, these are 149 countries defined by WHO who have tropical and subtropical conditions. And in these areas, which are also LMIC countries, more than 80% of people live with diabetes, and 88% of deaths related to diabetes occur in these countries. So the burden is quite high and morbidity is also quite high. And the factors which have a role to play include undiagnosed and poorly controlled diabetes mellitus. They are quite high in these tropical countries. And needless to say, infection also goes along with that. So when we are talking about infections, we are also looking at looking few years next, and we see that we have a huge burden of around 150 million diabetics in the Southeast Asian region, and so you can understand how big a problem will be the infections and its attendant morbidities and mortalities, and that is why we discuss this topic in this forum, a topic of importance. So what are the limitations that these tropical countries have, which we need to look into? So first thing is a big number of patients who are unknown, untreated, poorly controlled. Then a high rate of antimicrobial drug resistance. That is why we see patients diabetic foot and other infections not getting controlled and going for a long time. Then we have increased rates of amputation in these tropics, in these regions. We have reduced less number of patients who have a good glycemic control and poor HbA1c levels, and that is something that aids, that causes or leads to lingering infections. And at every stage, like reduced access to diagnosis, maybe because of financial condition, economic status, less awareness of diabetes status, and dietary interventions, inadequacy of that, inadequacy of monitoring of toxicity. And so these are various factors in the tropics that contribute to these infections. Now, a lot of factors play a role in promoting or causing or developing the infection in diabetes. As we see, altered skin flora, gut microbiota, autonomic neuropathy, peripheral neuropathy, increased intestinal permeability, or disorders of the immune system, impaired function of complements, or reduced apoptosis, neutrophil migration, NK cell impaired function, APC impaired recruitment. All these are factors which play a role and increase the risk of infection in diabetes. Now, coming to the various tropical infections or tropical syndromes that we come across, this is probably the most common and easily identified diabetic foot infections, and they cause a lot of morbidity and mortality. As we all know, neuropathy and peripheral vascular diseases play an important contributory role, and it causes morbidity, amputation, mortality, and as per data, 45,000 legs in India are amputated yearly, which is quite a big number. So this is the diabetic foot infection, which is common in the tropics. Similarly, we have a diabetic hand syndrome, and this is even more aggressive than the diabetic foot. It's usually found in Africa and Asia, and the same thing, there is a cellulitis, there is ulceration, there is sepsis, there is gangrene, and it occurs following trauma. So again, this is one of the other syndromes that we can find in the tropics in our countries. Now, this is mucormycosis. Again, during the COVID pandemic, this condition was a dreaded condition. So this is also an aggressive fungal infection which is found in diabetes, caused by zygomycetes, and there is a rapid progressive tissue necrosis in this condition, and it usually affects the it presents as a rhino-orbitocerebral disease, but can also have pulmonary, cutaneous, GI, and dissemination in the body. And it portends, it has a high rate of mortality, so that is all the reason why it is usually dreaded. Now, coming to the other conditions, like how diabetes has an effect. Does it have an effect on tuberculosis? Yes, it does. People with diabetes have at 3 times increased risk of developing active tuberculosis. So as you can see in this review from Lancet, published in Lancet Diabetes Endocrinology, the diabetes has been found to triple the risk for active tuberculosis. And not only that, tuberculosis patients with diabetes have a lower concentration of the tuberculosis drugs and a higher risk of toxicity in those as compared to those who do not have diabetes. So there is increased rates of death, there is increased rate of treatment failure, and also recurrent disease in diabetes mellitus. So tuberculosis and diabetes is a difficult condition. Then effect of diabetes on HIV. Now, there is usually there is glucose metabolism disorders, and there is an interaction with ART therapy or antiretroviral therapy. So as this study from Tanzania published in PLOS One it has shown that HIV-infected adults on long-term ART had a 5-fold greater odds of glucose metabolic disorders than HIV-negative control. So once we have these HIV patients on ART for a long time, they have some metabolic disorders, they develop some metabolic disorders and dysglycemia in the long run. Now, on the other side, this is another publication in HIV Medicine 2009, the risk factors of incident diabetes among HIV-infected patients. So this is 824 patients were studied in Taiwan, and it was found that people living with HIV have as much as 6-fold more chances of developing diabetes than the rest of population. So there is a link, long-term link with HIV and diabetes. So incident diabetes mellitus was associated with the family history of DM, exposure to zidovudine and protease inhibitors. So as we see, there is a link between the disorders, and it gives a 6-fold high chance of having a diabetes mellitus. Next, come to the very important tropical disease, malaria. So how does diabetes have a role in it? Now, this paper is from Emerging Infectious Diseases, Type 2 Diabetes mellitus and Risk of Malaria Infection. So what the authors have concluded that the falciparum infection leads to hyperglycemia, and which inhibits immune cell function against liver and blood stage parasites. So there is a 46% increased risk for infection with falciparum in patients with diabetes mellitus. Increase in diabetes mellitus prevalence may put more persons at risk for malarial infection. So this is what was found in that study, and there is an immune cell dysfunction in the liver and blood parasites as a result of diabetes mellitus, which portends more chance of having a malaria or its serious effects. Then comes leprosy, again an important infection in the tropical countries. So this publication in Hansenol International, it was shown here that increased incidence of diabetes, random normals had only 2%, whereas leprosy patients had incidence of diabetes to the tune of 14.2%. So a higher rate, a larger number of leprosy patients were found to have diabetes mellitus. Higher incidence of 19.3% of diabetes was found in lepromatous leprosy as compared to the tuberculoid leprosy. So here also we see that the incidence of diabetes in this study particularly found to be higher in diabetes patients. Now, melioidosis, this is something that over the last 10 years, almost everybody has seen a lot of patients of melioidosis presenting in various forms. So now it is beyond doubt, it's established, it is long been recognized as for its association with diabetes, and it can cause sepsis, pneumonia, abscess, and the organism is usually the Burkholderia pseudomyeli. Now, it has been proved that the interleukins and all have been found to be significantly elevated in blood from poorly controlled diabetic patients, and that is something which helps or progresses the pathogenesis of this disease. Now, there is a dysregulated PMN function in diabetes mellitus and monocyte response in diabetes mellitus, and so the response to pseudomyeli or the response to this organism is poorer in diabetes patient, as a result of which there is altered inflammatory profile and more serious infection. Similarly, this is another publication in PLOS neglected tropical diseases. It was seen that people with diabetes have a 12-fold increased risk of melioidosis, and over the half of patients with melioidosis have diabetes. This was a study which was published in this PLOS journal. So melioidosis patients with known diabetes had poor diabetic control and showed a stunted pseudomyeli specific cellular response. So the response to the organism, the immune response to the organism is also impaired in diabetes, and so we have more complications here. Next is scrub typhus. Now it's a ricket cell disease. For scrub typhus, there is an independent association or independent risk factor. Diabetes is an independent risk factor for scrub typhus. So, published in American Journal Tropical Hygiene, this paper shows or has recorded diabetes mellitus as an independent risk factor for scrub typhus, apart from age and a group of underlying disorders, heart, cardiovascular, cerebrovascular diseases, or CLD. Diabetes also is an important risk factor for scrub typhus. Then pyomyositis or staphylococcal infection we commonly see in our clinical work. So invasive staphylococcal infection is common in diabetics, and so is also pyomyositis. This study published in Korean Journal International Internal Medicine, it was the patients with pyomyositis were studied, and it was found that 9.7% of the patients had underlying diabetes mellitus. So diabetes is an established risk factor for invasive infections, and is also the commonest cause of pyomyositis. So we definitely have an increased association in patients who have diabetes mellitus. There is also a link found with salmonella. Diabetes mellitus was an important underlying disease in patients with localized infections in salmonella. Of course, this is a study published in a Scandinavian journal quite long time back, but it definitely shows some increased risk in diabetics. Then is dengue. With dengue and diabetes, we have quite a strong association here in the following. There is an increased severity of thrombocytopenia. There is 2 to 3 times increased risk of severe dengue. There is increased risk of acute kidney injury, and there is increased admission to ICU in diabetic patients. So if it's a dengue with diabetes, it is usually moderate to severe dengue. So this study published in International Journal of Molecular Sciences, the dengue affected patient with diabetes had a lower platelet count and a higher rates of various diabetic complications. Then of the last 4 to 5 years, when we had this COVID, the SARS-CoV and the severe acute respiratory syndrome, in all these cases, the association with diabetes was quite strong. And in SARS, which was Middle East respiratory virus, this study in Lancet Infectious Diseases, underlying comorbid condition, diabetes, 68% patients were found in that study in Saudi Arabia to have diabetes mellitus. Therefore, a strong association of SARS with diabetes mellitus. Similarly, with COVID and diabetes mellitus, a strong association. So we find increased severity of COVID-19 in diabetics, and COVID-19 predisposed infected individuals to hyperglycemia. Those who had COVID also found to have hyperglycemia. It's bidirectional effect. One is a cause, and also it leads to hyperglycemia. Then we have some viruses which also have something to do with glucose metabolism. Enteroviruses, Coxsackie, mumps, rubella, cytomegalovirus. They found to cause fulminant type 1 diabetes mellitus. An acute presentation of diabetes mellitus has been seen with these viruses. This we do not find, but yes, there is an association also with Chagas disease, as is found in the Brazilian journal, published in that. It was found to be an increased chance. Then strongyloidosis also, the disseminated strongyloidosis or hyperinfection was found to be more in diabetic patients, as is in this published in Indian Journal Medical Microbiology. The last thing you can see is strongyloidosis causing pericardial effusion in diabetic patients. So there is more chance of dissemination. So the key observations, as we see, dengue has quite a strong association, and apart from that, all these diseases are leprosy and schistosomiasis or leishmaniasis. There is some association has been found in the studies. So we can say that some infections are severe and almost entirely confined to diabetes mellitus, like rhinocerebral mucormycosis, malignant otitis externa, panophthalmitis, and Fournier's gangrene. These are very, very specific for diabetic patients. Then we have some diseases where diabetes association is significant, like melioidosis, pneumonia by Klebsiella, or abscesses, or emphysematous pyelonephritis, very strong association with diabetes. And there are some, there is a potential inverse interaction. This is quite interesting. Cystosoma and filariasis have an inverse association, but of course these are not very strong, but in areas, in some studies, have been found to have an inverse association with diabetes mellitus. So I will conclude here by saying that diabetes increases incidence and severity and affects treatment outcomes of a large number of infectious diseases, and it puts a heavy burden on the healthcare service. And antimicrobial resistance, healthcare infections, these are challenging things for us in the tropics, which we need to take into account. And interaction between diabetes and infectious is another reason why prevention management of this disease is very important. I'll conclude here. Thank you for your patience here.
Thank you, Dr. Anupam, for the crisp coverage of this extensive topic in time. We can take 1 or 2 questions from the audience.
Yes, so like we have the strongyloidosis in which you can have a disseminated, you can have an infection, that is fine, but when it's disseminated, that is where diabetes role comes to play. So you have like strongyloid disseminating causing pericardial effusion, you will not find in normal, but diabetic or immunocompromised you can find that. So whenever you have a disseminated helminthic infection, do look for diabetes mellitus and glycemic control. Yes. So what? Definitely. So that is what the point I was driving home is that what they have encountered is a pulmonary eosinophilia secondary to a helminthic, disseminated helminthic infection when they cause the respiratory symptoms. So we can expect that in such patients there should be an underlying immunosuppressed state. Diabetes is one of them, maybe diabetes or HIV or CKD or whatever. Some underlying immunocompromised state is there. So that is why you have got this infection.
You have cited one that pathogenesis, the mechanism from diabetology.
Yes.
Yes. That journal I have gone through, and they have included mellidosis as one of the diabetes defining infection. But this is the latest information because so rampant in diabetes. Diabetes is a predisposition like your pyloric emphysematous complications, rhinocerebellar necrosis, and our fungal infections in genitalia. All these things. Mellidosis also now as introduced as a diabetic defining infection in this diabetology.
Yes.
Thank you.
Yes.
And what sir told, that is maybe a case of low floor syndrome, I think.
Yes.
Low floor syndrome.
Pulmonary eosinophilia.
Thank you, Dr. Anupam,
Thank you.
for
Thank you.
wonderful talk.
Now, after knowing the pathophysiology of diabetes mellitus, after knowing what are the infections and topical infections that are very common in diabetes mellitus, now as we know by this time, diabetes can predispose to so many infections. Now when the question of infection comes, naturally in our mind the next thing will come, is there any vaccine or what vaccines we can administer to control these complications of diabetes mellitus. And if at all any vaccine is available for diabetes itself, primarily we have two types of diabetes. One is type 1 and the other one is your type 2 diabetes. Is there any vaccine in near future available for any type of diabetes mellitus? So myself, Dr. Professor Chandrasekhar Mahapatra, I am from SCB. I am privileged to introduce my next speaker who will speak on vaccines in diabetes mellitus, and the speaker is Dr. Mahesh Rath, and he is having 10 years of experience. He is treating in the line of diabetes, endocrinology and other infectious diseases. In addition, he is involved in undergraduate and postgraduate teaching in High Tech Medical College, Bhubaneswar, and he is the consultant in diabetes, thyroid, adult vaccination in Kalinga Hospital, Bhubaneswar. And now I would like to invite Dr. Mahesh Rath to give his deliberation about the vaccination in diabetes mellitus.
Thank you, sir. Thank you for the kind introduction. A very good evening, everyone. So, first and foremost, my love and gratitude for Professor Dr. Jayant Panda, sir, and the organizing committee for having me here. So my topic is vaccination in diabetes. Diabetes, we all know, is chronic hyperglycemia, and the immune system becomes compromised, making the diabetics more susceptible to infection and complications as compared to normal individuals. Here, vaccination plays a very prominent role in reducing the mortality and the morbidity of the patients. So if we look at the immunocompromised state in diabetes, so those with poor glycemic control are at increased risk of infection due to several factors, and hyperglycemia can impair the immune response by first inhibition of the neutrophil function. So elevated blood glucose level can impair the neutrophil chemotaxis, phagocytosis, and the microbial killing, which are essential processes for the innate immune response. Secondly, reduced T cell function. So chronic hyperglycemia can lead to glycation of proteins, including those involved in the immune response, resulting in impaired T cell activation and cytokine production. Third, altered complement pathway. Hyperglycemia can lead to glycation of the complement protein, reducing their ability to opsonize pathogens and activate the immune system. So given these immunological impairments, diabetic patients are more prone to infections such as influenza, pneumococcal disease, hepatitis, underscoring the importance of vaccination in this population. So if we go to the vaccine or the vaccine preventable diseases in diabetes patient, first comes influenza. The most common vaccine that we give is the influenza vaccine, and it, among the diseases, it accounts for the maximum hospitalization and mortality compared to non-diabetic population. The ADA and the CDC recommend annual influenza vaccination for all diabetic patients. So studies have shown that those who are vaccinated with the influenza vaccine have got reduced risk of hospitalization. So also a study by Lau et al. Has shown that influenza vaccine reduces the risk of all-cause mortality by 24% and hospitalization by 30%. So the dose is annually one dose which is taken intramuscularly in the deltoid. Second comes the pneumococcal disease. It is caused by the Streptococcus pneumoniae and can lead to severe illness such as the pneumonia, bacteremia, and meningitis. The CDC recommends that diabetics between 19 to 64 years receive the PPSG 23 with a follow-up dose after 65 years. Those who are more than 65 have to take a P13 and then follow it up with a PPSB 23 after 1 year. The introduction of the PCV13 has further improved the protection, especially in older adults, as I mentioned, more than 65. So studies have shown that there is decreased incidence of invasive pneumococcal infection in diabetic patients who are vaccinated with the pneumococcal vaccine. The dose, the P13 or the PCV13, more than 65 years, it is one dose. PPSB 23, it is for the age group of 19 to 64. And the booster dose is every 5 years. If we give a PCV13 to anyone who is more than 65, follow up after 8 weeks with a PPSB 23 and then booster every 5 years. It is also given intramuscularly in the deltoid. Next is the hepatitis B. Hepatitis B is a vaccine which is the most common vaccine, particularly in people who who have frequent medical interventions and live in communal settings. CDC recommends hepatitis B vaccine for everyone. Increased susceptibility of HBV in diabetes patient is thought to be related with the frequent use of blood glucose monitoring devices. If they are not properly sanitized, they can transmit the virus. Studies have shown that incidence of acute HBV infection was higher in diabetic patients compared to non-diabetics. So, although this is a part of the normal immunization schedule, but with age the immunity decreases, so we need to do the HBsAg titer. If the titer is less than 10, then we need to take the vaccine. If it is more than 10, then vaccination is not required. Dose is 0, 1 and 6 to 12 months. The third dose, intramuscular in the deltoid. Hepatitis A, although not a very common vaccine, but because of the susceptibility to hepatitis in diabetes patient, this is also one of the vaccines which can be considered. The CDC recommends the hepatitis A vaccine for people with chronic liver disease. It is highly effective and 95% of the individual developing protective antibodies after the second dose. It is very safe and just minor injection side effects can happen. Dose is 0 and 6 to 12 months is the second dose, intramuscular in the deltoid. So studies have shown that if the hepatitis B vaccine and the hepatitis A vaccine are given in combination, then it has got a much more better effect or the additive effect as compared to each of them being given separately. Now this is the COVID-19 vaccine. So COVID-19 vaccine we are all very familiar with. We had the Covaxin, we had the Covishield, the Sputnik was also here. The protectivity, we have all seen it, that from the first wave to the second wave to the third wave, the incidences of COVID-19 decreased and most of the benefit or most of the credit was given to the vaccination. About the dose, it varies according to the brand that you are taking or the molecule that you are taking. DPT, diphtheria, pertussis, tetanus. So, because diabetes patients have a chance of a delayed wound healing, making them more susceptible to infections like tetanus, they should be vaccinated with a DPT vaccine. So if it is given once, then you can follow up with a TD vaccine every 10 years, so that, and it gives protectivity so that every time you have an injury, you do not have to take a tetanus toxoid. If every 10 years you are taking a TD, but being a diabetic, because the immunization status is not known or the protectivity is not known, one dose of DPT should be taken. MR, measles, rubella, both of them are very deadly diseases. While not specifically more dangerous to the diabetic, but as I told, they are dangerous diseases or the infections, and protection against them is very much warranted, because any infection which happens in a diabetic flares up very soon, goes into complication. That is why this vaccine should be taken, 2 doses, 0 and 1, subcutaneous in the deltoid region. Herpes zoster, one of the most important vaccine which should be made compulsory to everyone more than 65 years of age, because herpes zoster leads to post-herpetic neuralgia. It can lead to death also. It can lead to meningitis, it can lead to death also. It is that serious, and the later age in which it manifests, the more severe it becomes. Although this is a very, very costly vaccine, was not available in India till last 1.5 years, but now this is available in India, and it is the most costliest of the vaccine. 1 dose is enough. HPV vaccine, if you ask me among all these vaccines which is the most important vaccine, then I will tell it is the HPV vaccine. This is the only vaccine which can give protection against cervical cancer. It should be given to everyone, regardless of the diabetes status or regardless of the age. Starts from the age of 9 years till the age of 26 is the CDC recommendation, but we give till the age of 45. Then in pediatrics, if you are giving in a private practitioner, then it is there. Of late, till last year, this was not approved in males, but now it is approved in males up to the age of 26 years, which protects from cervical cancer, genital warts, sexually transmitted diseases, testicular cancer, penile cancers, genital warts. So all these are covered by this vaccine. There are only 3 doses, 0, 2 and 6 months, intramuscular in the deltoid. The girls who are taking or the boys who are taking with 9 to 11 years, only 2 doses are required, 0 and 6 months. Last is the BCG vaccine. Last year only the pilot study of adult BCG vaccine has been started in Nagpur because of the increased incidence of tuberculosis in the society. So because BCG is the first vaccine which is given at birth, every one of us has that mark on our left arm. So over the years, over the time, its effectivity decreases. So now latest is the BCG, adult BCG dose, which should be given with the hope that it will decrease the new cases of tuberculosis in the society. Now in Nagpur it is in the pilot stage, but it will be implemented throughout India very soon. Future directions and research. First of all comes vaccine development. More and more vaccine needs to be developed so that we are protected or we have a better protection against all the variety of diseases which are happening in the society. Then longitudinal studies regarding the vaccine response and the effectiveness in diabetic patients should be there. We do not have much of these studies on the effect of vaccines on diabetic patients. We should be doing the studies. Third is the impact of new vaccines. Introduction of new vaccines such as those of the RSV or emerging infectious diseases should be closely monitored in immunocompromised patients such as diabetics. Fourth, personalized vaccination strategies. I have mentioned 10, but that is not the whole list. There are other vaccines also which can be given. So because I actively practice adult vaccination, that is why I give an array of vaccine options to my patients. According to that, as we are talking about personalized medicine or the precision medicine, like that only, we should practice precision vaccination or personalized vaccination so that we can impart or we can pass on maximum benefits to our patients and help them get protected. Concluding, vaccination, as healthcare professionals, we know the importance of vaccination, how crucial it is, and we should actively promote vaccination and also actively take vaccination. Whichever vaccination are applicable to us, we should take it. Adult vaccine is not covered by the government. Everything has to be paid for, but it is much lesser than one incidence of hospitalization. Despite challenges, vaccination reduces the mortality and morbidity. The brightest example recently has been COVID, in which people have known the importance of vaccination. So by addressing the vaccine hesitancy, improving healthcare access and continuing research into vaccine response in diabetes patients, we can enhance the effectiveness of the vaccination programs and improve the outcome for the vulnerable population. When we are using more and more of vaccine, when it is more vastly increased, then and by creating awareness programs, maybe the government may include it in a geriatric program, or the prices of the vaccines can come down in near future. Thank you.
Now, thank you, Dr. Mohesh, for a nice account of vaccination in diabetes mellitus. Now we can take one or two questions from the audience.
Sir. Sir, presently COVID vaccines are not available because it is 100% controlled by the government. Regarding the side effects that you are saying, within a short span of maybe 6 months they have developed the vaccine. The bigger benefit of the vaccine may be 5% of the population developed the complication, but it has benefited completely to 95% of the population. And we should look at the bigger picture, that it has protected scores, lakhs and crores of people. It has protected them, and as such every vaccine, I have given influenza vaccine maybe in thousands, but there are still incidences of patient developing a fever. I do get maybe 1 in 1,000 patient develops a fever. Does not mean that I'll stop giving an influenza vaccine. Same is that when we are giving in crores, then 5% makes matter. It matters, and that comes up because of the wide media coverage. No one will go to the media and say that Dr. Mahesh gave me an influenza vaccine and I developed fever. But when it's a COVID vaccine, when it's a hyped one, then obviously they go to the media and try to say it in a more larger way. Every age patient can take it, sir. More than 18 years, because if the proper pediatric vaccination schedule or the chart is available, then need not take this, only influenza vaccine will do. But if the proper vaccination card is not available, you do not know the vaccine status, then taking it will not do any harm, because these are all killed vaccine. As such, it will improve the immunization status. So these vaccines are extremely safe. Except the live vaccines, all other inactive vaccines can be taken. If you have not taken, then you can easily take it. They do not come. At any age it can be taken, more than 18 years, because we are dealing with adult vaccine. So more than 18 years of age, it can be taken. Sir, please.
Yes, yes.
Nobody is studying. So don't think that if you have taken a vaccine at 90 years of age, it is highly effective as equal to as 19 years of age.
No,
exactly.
Senescence, immunosenescence. Then again, I am stressing on the immunogenetics. Differs from individual to individual. The same vaccine given to 19 years old male, 6 males will have 6 different immunological responses.
yes, you are right.
Cellular immunity, the humoral mediated immunity will be just be different. It's not same. But vaccine should be given. And as far as the COVID vaccine is concerned, he was right in saying whether we have post-vaccinal myocarditis or vaccine-induced thromboembolic phenomena that we recorded was same. But now a different era of post-vaccinal autoimmune diseases, whether it was because of natural infection or because of COVID vaccination, for example, UBI, for example, hepatitis, for example,
Diabetes, a lot of have developed diabetes also.
So because whether the COVID virus caused an immunological dysregulation or the vaccine caused the immunological orchestra has been dysregulated, we are not
That's not clear
but
until now.
COVID, we are
Now the essence of talk of Dr. Mahesh is that if we still immunize the adult immunization schedule, you know, whatever he has described from BCG, DPT, MR, everything we are giving to the child, and we are following the immunization schedule. But what is his essence of the talk is that even if we are adult, we can give vaccination to the adult to minimize the morbidity and mortality of the diabetes mellitus arising out of so many infections. So that is the idea, I think. Anyway, thank you so much for your...
Dr. Mahesh, one clarification.
Yes, sir.
You told about pneumococcal vaccine.
Sir.
After the age of 65, you probably told
PCV 13.
one dose of PCV 13 followed by
PPSV 23.
after how many?
Minimum 8 weeks. Minimum 8 weeks.
Probably the general recommendation is PCV 13, one dose after 65, followed after 1 year of PPSV.
The minimum is 8 weeks, but generally if the patient is not vulnerable, we give it at 1 year. But the
recommendation is probably after 1 year. PCV 13, then after 1 year, the
About
PPSV
pneumococcal.
23.
immunocompromised, it is 8 weeks. 8.
And
Immunocompromised.
Shingrix vaccine you told, no?
Shingles.
Shingrix vaccine.
Yes.
You told one dose.
Zoster. Yes.
You told one dose.
Yeah. This
Probably
one
they are
dose.
recommending 2 doses of Shingrix vaccine.
And this is not frequently administered, is not available as
2
well.
doses, 1 dose followed 4 to 8 weeks. Second dose.
20 has not come yet, will come. It is.
15 and
It has
PCV
not
20 are
come.
not yet approved in India.
Not yet approved.
Most important vaccine, that is influenza vaccine, everybody should take, because there is strong evidence that if you are taking influenza vaccine, there is decrease in the morbidity and mortality as regards to coronary artery disease, because it has been found that influenza precipitates many coronary artery disease. So everybody, every diabetic at least, they should take it. And another very good thing in diabetic is that though all the immunities, all the natural immunity or cell mediated and humoral immunity are affected, B cells are also affected, which affects all our global burden of your antibody, local antibody. But surprisingly, your whatever vaccines you are giving, they are working in our body. That is the God's grace to us. Despite affecting our humoral antibody, also vaccines are acting in our body. Most important thing. And recently we are getting PPV 20, perhaps there is single dose. Thank you.
Thank you, sir.
Okay.
Thank you, Mahesh, for your excellent talk. I will add one thing. As the KDIGO guideline for CKD, we are giving the hepatitis B vaccine, just double dose of the,
yes,
2 ml, both delta, deep IM, 0, 1, 2 and 6. And if the level of immunoglobulin is below 10, then we are giving the augmentation by GMCSF. So is there any recommendation here in the diabetes like that? Because they are also
No, ma'am.
immunocompromised.
Only in severely immunocompromised, as you are told, the KDIGO guideline says, but the ADA and the CDC guideline do not say to give double dose. In CKD patients, they are in, the KDIGO suggests that 2 doses are given, 1 ml in both the deltoids. That
And
is
the dose also 4 doses. Here
doses,
is 3
yes.
doses. But
Yes,
here
yes.
0, 1, 2 and 6.
Yes.
And augmentation also advised. Yes.
because of the severely immunocompromised state. But
Because they are exposed to the blood circulation
Yes,
twice weekly, that's why.
ADA does not say that. Thank you, sir.
So now it became a interactive session in true sense. So thank you, Dr. Mahesh. Now we conclude this session.
SCB. Dr. Ravi Shankar Sahu, Assistant Professor, Department of Medicine, SGMC, please. And Dr. Samir Swai, Professor and HOD, Department of Urology, SCB. Please start the session.
Very good evening to one and all. May I invite Professor Dr. Arvind Jageshia to deliver his talk. He is the Chairman and Chief Diabetologist, Dr. Arvind's Diabetes Care, Bengaluru, India. He has vast experience of working in various hospitals in UK, especially in the field of diabetes and endocrinology. He is one of the few with MRCP and triple FRCP. Over 100 conference presentations, 30 publications, and involved in clinical trials conducted at Dr. Arvind's Diabetes Center. He was the president of RSSDI Karnataka chapter 2018-19, and he is presently the executive committee member of RSSDI. A warm welcome, and please let's begin.
So good evening everybody. At the outset, I thank Dr. Jayant Panda for making me a part of this conference. Thank you madam for the nice words. So we are discussing an important topic about hypoglycemia today. So it's hypoglycemia, a clinical challenge in diabetes care. I'm sure all of you will agree on this. So first of all, greetings to all of you from Bengaluru. So this will be the table of contents. So hypoglycemia is one of the most difficult aspects of diabetes management. According to the definition from ADA, so any abnormally low plasma glucose concentration that exposes the subject to potential harm with a proposed threshold plasma glucose value of less than 70 milligrams per deciliter, you call them as hypoglycemia. If you go for the classification, there are 3 levels of classification: level 1, level 2 and level 3. Level 1, when there is a glucose value, is between 54 to 70. Level 2 is less than 54. Level 3, a severe event characterized by altered mental and or physical status requiring assistance for treatment of hypoglycemia. So this is an important slide to show the counter-regulatory hormones and actions. The first one is the insulin. We know it from beta cells and pancreas. What does it do? It suppresses the hepatic glycogenolysis and hepatic gluconeogenesis, suppresses the glucose production. Next one is the glucagon produced by alpha cells in pancreas. It stimulates the hepatic glycogenolysis and gluconeogenesis. Epinephrine and sympathoadrenal system from the adrenal medulla. It suppresses again the hepatic glycogenolysis and hepatic gluconeogenesis, limits glucose clearing the peripheral tissues and suppresses the insulin secretion. The cortisol, it is a growth hormone, the adrenal cortex somatotrophic cells, that is anterior pituitary, it produced, and it increases the glucose production, limits glucose clearance, and effect is delayed for hours. So these are the glycemic thresholds for secretions of counter-regulatory hormones. You can see on the left hand side, when the sugar is less than 4.6 millimoles, there is an inhibition of endogenous insulin secretion. Next, when it is around 3.8, there is the counter-regulatory hormone release, that is the glucagon and epinephrine. Between 3.2 to 2.8, that is onset of symptoms like autonomic symptoms and neuroglycopenic symptoms. 2.4 to 3, the neurophysiological dysfunctions occurs. Around 3, there is a widespread EEG changes. Around 2.8, the cognitive dysfunction starts. less than 1.5, the severe neuroglycopenic symptoms, that is reduced conscious levels, convulsions and coma will come. So these are the various physiological aspects which occurs when a person develops hypoglycemia. So you can take the prevalence of hypoglycemia. The several large-scale clinical trials have demonstrated the incidence and prevalence of hypoglycemia in patients with both type 1 and type 2 diabetes. The rates of severe hypoglycemia are more common among older adults and those with chronic conditions such as CKD, CVD, heart failure, depression and higher HbA1c level, as well as among those who are on insulin or taking secretagogues. So there are a few learnings from the DCCT trial. So what does the trial say is that it's more than 1,000 episodes of loss of consciousness associated with hypoglycemia. Even with treatment, there are reported cases of long-lasting severe hypoglycemia leading to transient and even permanent cerebral damage. So hypoglycemia that is not reversed can progress from lethargy to coma and ultimately to death. So the percentage of severe hypoglycemia events in various studies, like the important landmark studies like ACCORD, ADVANCE and VADT, you can see here, even in ACCORD study they've seen up to 16% of the patient going in for hypoglycemia, 2.7% in ADVANCE, and VADT is 21.2%. So the mortality, increased mortality has been observed in randomized control trials during more aggressive compared with the less aggressive glucose lowering therapy. That is why when you're treating a diabetes, it should be always individualized. We should not concentrate on only HbA1c less than 7 or 6.5. Younger the patient, go aggressive. Elder the patient, just relax a bit. Because if you go on going aggressive mode, they may land up in hypoglycemia and sometimes irreversible damage. So individualized treatment is more important. Nowadays we have got more medications like newer medications like SGLT2 inhibitors or GLP-1 RAs, where the incidence of hypoglycemia is very less. That is much more beneficial to our patients. So what are the risk factors? We have the conventional risk factors like insulin doses. Sometimes what happens, the patient takes insulin doses inadvertently or ill-timed or the wrong timings. Then there is second one, the intake may be less. Accidentally he misses the food, or because of some function or some religious aspect, they may skip the meal, but they religiously take their medication. They'll end up in hypoglycemia. Third one is glucose utilization and sensitivity to insulin are increased as during and shortly after exercise. Sometimes patient becomes more motivated all of a sudden by seeing some videos. They start exercising very aggressively, they were not doing it earlier. This may land patient in hypoglycemia. Then insulin clearance is decreased. As we all know, in patient with renal dysfunction, that is chronic kidney disease, suddenly the patient may go in for hypoglycemia because of the decreased insulin clearance. Classically, diabetic autoneuropathy patients also may land up in hypoglycemia. So other risk factors in general, if you take advanced age, when there is a craving for tight glycemic control, renal insufficiency, pregnancy, multiple diabetic medications, low diabetic knowledge, type 1 diabetes, insulin-dependent type 2 diabetes, and previous hypoglycemic episodes. These are the other conventional risk factors. So these are the putative mechanism which shows the hypoglycemic unawareness. You can see the person who is developing recurrent hypoglycemia, how the diminished autonomic response to hypoglycemia occurs. So in these patients, they have hypoglycemia, but they are unaware. Why? Because they don't have typical symptoms because of the increased GLUT1 activity, altered VMH sensing of glucose, increased GABA levels in VMH. So they don't have regular symptoms. What regular symptoms are there? They have reduced sweating, part of glucagon production under autonomic control, absence of palpitation, reduced production of catecholamine, absence of tremor. This can be a big danger when we are managing our type 2 diabetes, because the patient has hypoglycemia but is not aware of the symptoms. He may land up in severe problems. So the mechanism by which hypoglycemia may affect cardiovascular events, this is also we should know, because we always think that hypoglycemia is what is there, you give some dextrose, it will improve. No, the question is, we should try to prevent the patient going in for hypoglycemia, because they may land up in various side effects, especially the cardiac side effect. You can see here in the middle, the hypoglycemia leads to sympathetic adrenal response, that is increased adrenaline, leading on to rhythm abnormalities and hemodynamic changes, that is increased contractility and increased heart workload. So these may lead to sudden death as well. So avoiding hyperglycemia is of primary importance. So what are the precipitants for hypoglycemia? The drugs, we know insulin and insulin secretagogues, others like gatifloxin, quinine, indomethacin. Physiological diabetic complications like gastroparesis, factitious like misuse of insulin, or excessive alcohol consumption. So most of the patient will ask you like, doctor, I am a diabetic, can I take alcohol? So this is the common question. But what happens most of the time, they take alcohol, they take medicine, they forget to eat food. So they'll end up in hypoglycemia in the night. So this can be a tremendous danger to the patient. The third one is the psychological or psychosocial, that is fear of hypo or hyperglycemia, denial, depression, and cognitive impairment. So these are the various precipitants where the patient go in for hypoglycemia. These are the traditional signs and symptoms of hypoglycemia, like pallor, diaphoresis, tachycardia, blurring vision, elevated blood pressure, palpitation, paresthesia, difficulty in concentration, hypothermia, weakness, warmth, anger, fatigue, I'm sure all of you know. Severe like emotional liability, including anger, giddiness, tense, anxiety, which most of us also would have felt like this. Why? When you are hungry. So when you are hypoglycemia, you may not be diabetic, but when you are having this hypoglycemia, these symptoms we might have also experienced in our lifetime. So diagnostic hypoglycemia, the diagnostic hallmark to identify hypoglycemia, this is the Whipple's triad, that is low glucose level less than 70, signs and symptoms consistent with hypoglycemia, and the resolution of signs and symptoms following an increase in plasma glucose level. So this is the Whipple's triad, which is the diagnostic hallmark to identify hypoglycemia. So what are the preventive strategies you want to do? So you can go for the ADA recommendation. The simple recommendation is that it's not a big complicated one. So the occurrence and risk for hypoglycemia should be reviewed at every encounter and investigated as indicated. Whenever the patient comes to your follow-up, just ask one question: did you have any low sugar symptoms? Did you have any sweating or anything like that? Just one simple question will tell whether the patient is going in for hypoglycemia. Second, glucose is the preferred treatment for the conscious individual with blood glucose less than 70. Although any form of carbohydrate that contains glucose may be used, 15 minutes after treatment, if the blood glucose shows continued hypoglycemia, the treatment should be repeated. Once the blood glucose monitoring or glucose pattern is trending up, the individual should consume a meal or snack to prevent recurrence of hypoglycemia. Third one is glucagon should be prescribed for all individuals at increased level of level 2 or 3 hypoglycemia. Insulin treated patients with hypoglycemia unawareness, one level 3 hypoglycemic event or a pattern of unexplained level 2 hypoglycemia should be advised to raise their glycemic target to strictly avoid hypoglycemia. Ongoing assessment of cognitive function is suggested with increased vigilance for hypoglycemia. Because older adults with diabetes have a greater risk of hypoglycemia than the younger adults, episodes of hypoglycemia should be ascertained and addressed at the routine visits. For older adults with type 1 diabetes, the CGM should be considered to reduce hypoglycemia. Now CGM is quite affordable if the patient is having erratic sugar, especially morning hyperglycemia, evening hypoglycemia. You don't know what is happening in that particular group of patient. You advise the patient to have a CGM, thereby you know the pattern, thereby you can adjust the medication. So what are the management strategies? Depends upon the conscious state and degree of cooperation of the patients. The first is, it always says the rule of 15. They say rule of 15. So 5 to 15 fast acting oral carbohydrate can be given. Half a glass of juice, 5 to 7 chocolates or jelly beans, 3 teaspoons of honey or sugar, glucose that contains 15 grams. Once again the 15 has come, 15 grams of carbohydrates. Then follow up with more slowly absorbed carbohydrate such as sandwich, biscuits, glass of milk or a piece of fruit. Retest the blood glucose level after 15 minutes. So this is the rule of 15. So where the 15 minutes you reassess the patient so that he is recovered completely. The next is the glucagon, 1 milligram. It can be given subcutaneous, intramuscular or intravenous. Can be administered by relatives or the ambulance crew. Response to this is slower than the IV dextrose. Need 7 to 10 minutes until the normal mental status. Will not work with the alcoholics, elderly and depleted glycogen store. Then you give 10%, 25%, 50% dextrose. Another important thing one to be noted is the octreotide can be given. It is a synthetic analog of somatostatin. It inhibits the release of insulin. It is used in the treatment of sulfonylurea-induced hypoglycemia. This is one important thing where you can consider, especially when some patient unknowingly, if some doctor is using glibenclamide still, they may go for a long-lasting hypoglycemia, then you can definitely consider octreotide as one of the mode. So, warning is, important thing you should keep it in mind is suggesting underlying pathology like stroke or the development of cerebral edema due to hypoglycemia. So maintain glucose level at 7 to 11 millimoles, contact ICU and consider mannitol or dexamethasone. If still the patient is unconscious, do a further investigation to rule out other parameters. So 90% patient fully recovers in 20 minutes. When hypo cause is identified and fully correct, the patient can be discharged after observation at ED or appropriate follow-up. So preventive strategies, the most important is to know the cause of hypoglycemia and address the issue accordingly. So adjust the medication, talk about diet, talk about exercise pattern, ask them to monitor regularly, and most important is the diabetes education. So these are the risk factors, and arrange the follow-up having the consider the following, means why did this episode occur, has there any recent change of regimen, other drugs, alcohol, etc. Is the patient developing hypoglycemia unawareness or autonomic dysfunction? Always be vigilant. So ADA recommendation once again says in older patients with type 2 diabetes at the increased risk of hypoglycemia, medication should be monitored and adjusted accordingly. Over-treatment of diabetes is common in older patients and should be avoided. De-intensification depending upon the sugar level has to be done. Always consider the costs of care for the prevention of hypoglycemia. So ladies and gentlemen, the take-home message from my talk is the threat of hypoglycemia is one barrier to provide optimal glycemic control in inpatient setting. Prevention is key in ensuring patient safety. Identifying risk factor, implementing protocol, avoiding traditional sliding scale insulin regimens, and changing unsafe prescribing behaviors are ways to avoid severe hypo events. Reviewing hypo signs and symptoms with the entire inpatient team, including patients and their significant others, allows for early detection and treatment. Establishing and publishing a simple treatment protocols affords prompt action to appropriately treat various stages of hypoglycemia. I am happy and thanks to Dr. Jayant Panda for keeping an interesting topic, because hypoglycemia is always one of the neglected topic and it is last kept topic. but this is one of the important thing to be carried out message, because we always think that hypoglycemia, what is that we can treat. The question is, avoiding hypoglycemia is an important aspect which can be done in our clinical practice with a simple education to our patient. Thank you for your patience hearing.
Thank you, Arvind. Actually, all who treat diabetes should know hypoglycemia very well, as the message has been passed on. Because it's not simply increasing or decreasing blood glucose, it's much beyond that. All the cardiac arrhythmias, all the autonomic dysfunctions, and series of events, the neurological, cardiological, as well as other system involvement, starts with this hypoglycemia itself. And we have seen people, senior executive, the ILS director of ODISHA was found dead in the Guwahati in the middle of the night, diabetic on insulin therapy. It is dead in bed syndrome. And only cause is, many have, you must have heard that the person is found dead. And then we tell that something happened. This is simple hypoglycemia, not hypoglycemia, followed by a series of autonomic dysfunction. So give a big hand to Dr. Arvind. He has given you a very good approach, that while approaching a patient, while starting a OAD, while starting a insulin, it should be in our mind that will train the patient to combat hypoglycemia, and especially nocturnal hypoglycemia. Nocturnal is very difficult. The patient doesn't know, the family caregivers are not there around, they're sleeping and they found the middle of the night, bad things happen. It has to be there in mind. And then rightly he has covered. I request the chairpersons to give their comments and take questions if any.
During your presentation there was one point regarding treatment of hypoglycemia with glucagon. Is it practically useful?
Yeah, it is there, because availability is a question always.
I am urologist, so I don't know.
Yeah,
still
in few centers, definitely it is. In Bangalore it is there. So we use that in a selective group of patient. What selective group of patient? You administer treatment for 25% extras, 50% extras.
No, it's may not be. My question is, it's almost in the hospital setting.
Yeah. Hypo kit is available, not now, since long. Hypo kit.
Hypo kit, yeah.
Yeah, hypo kit contains glucagon, and then it's for emergency use. When even patients who are quinine-induced hypoglycemia refractory are there, we have used that. It's an emergency drug available in the hospital setting.
Most of the time hospital setting.
Usually hospital setting.
And the thing is, if the question is, the patient should not go in for hypoglycemia repeatedly.
Okay.
In US and all, the family members have keep it at home, and even the ambulance crew has got. In India, not that stage, but in a hospital setting, definitely it is.
Glucagon is useful. Okay.
Yeah.
Thank you.
Yeah, that depends upon the overall associated situation. There is no particular time, but only thing is, if you take the rule of 15, you identify the patient with hypoglycemia, treat him, 15 minutes he has responded. If he is not respond, again treat him, like 25% dextrose, 15% dextrose, then glucagon. If still is not responding, then there is something that is happening. That is a rule of 15 is there. Octreotide, yes, if the patient is on sulfonylureas. Not for all, patient is on sulfonylurea, there is benefit is there. Yes, madam.
Thank you, sir, for your elaborative talk. I will give one comment. In CKD ESRD patient, due to very high level of uremic toxins, there is one term known as uremic diabetes, because of that resistance of the insulin receptor due to uremic toxins. So in those cases, due to very high level of hyperglycemia, we are using very high level of insulin. But when we are taking those patients for dialysis, suddenly there is drop up due to washout of the uremic toxins. Yeah. There is sudden severe and dreaded hypoglycemia, and in that case very difficult to survive the patient. So it is very important in those cases be aware of that we should not administer very high dose of insulin, or rather to avoid insulin and go for the dialysis.
Absolutely, madam. That is a very important point what you told, because one of the clinical challenge in CKD is avoidance of hypoglycemia.
Yes, sir.
The patient comes to you with a big high sugar, 300,
Yes.
400. We discuss with, we know that you start with the small dose also, 10 units also you start. After dialysis or something, you land up in hypoglycemia.
Another thing is most of the CKD, ESRD, there is resistant hypertension, and the one cause is sympathetic overactivity. For that we are giving the beta blockers, and those beta blockers may cause hypoglycemia on awareness.
Unawareness. It masks hypoglycemia.
Yes. So those two things.
Yes.
Thank you.
Thank you. Yes, sir.
For your extensive talk on hypoglycemia, but two things what we encounter, unable to detect, is hypoglycemia unawareness. That you have explained, of course. But how to identify that and how to address it, first thing. Second, our chairman also said about a nocturnal hypoglycemia. What message would you like to give? 3 a.m. is hypoglycemic, there is dawn phenomenon, hyperglycemia in the morning. So what advice should be given? Whether it is an OAD or whether it is an insulin, what should be your message to us?
Main thing is hypoglycemia unawareness and nocturnal hypoglycemia is about the overall associated medical problem, and the patient has got autoneuropathic symptoms. So the main thing is to rule out the autonomic neuropathy. Like whenever the patient comes in, you ask about, you examine the pulse rate and all those things. Awareness is the most important thing. If, for example, if the patient is an elderly patient, is having associated comorbidities, long duration of diabetes is there, we should make sure that in the middle of the night, a few questions should be asked. And few questions is that sometimes if the patient is autonomic neuropathy, he may not be aware what is happening in the night. When you discuss with the family members or as a team, collective team, you'll come to know. At that particular point of time, now the plus point what we have got is the CGM facilities are there. CGM, the CGM, if you just apply over it, and definitely many patients are being detected, like early morning 3 o'clock, 4 o'clock, they are sleeping and they don't know their sugars are 40, 50. Then the morning when the relatives go and try to wake them up, they are not getting up. So patients say, I don't know, doctor, I am taking medication. I don't know. What you said, I am taking it, but I am developing these things. So at that point of time, CGM plays an important role, and that itself helps you in altering the medication accordingly and preventing these phenomena.
So, thank you, sir.
Thank you.
The topic is early diagnosis and reversal of DKD. For this session, our speaker, Madam Dr. Aruna Acharya, Associate Professor and Head, Department of Nephrology and Transplantation Medicine, SC Medical College and Hospital, Kotak.
Let Madam adore the dais till then.
Actually, all invited faculties are best in their field. I am not telling the state faculties are less, but Odisha has always taken the theme of Atithi Devo Bhava, and he has a custom of putting a Karnataka pagada and all malas in his program, and erudite scholar. I request Professor Tripathi to felicitate Arvind with a small memento.
I have listened with rapt attention of Basically, he taught us everything what we should know in practice. I have just completed 60 years of practice this time. ମ୍ୟାଡ଼ାମ୍ ଆସନ୍ତୁ ଆପଣ ସମସ୍ତେ
Thank you. Congratulations. Very well spoken. Thank you, sir.
So, Madam has immense knowledge in field of transplantation. She has MBBS gold medalist, MD gold medalist. So I would like to invite Madam and give some knowledge in field of diabetes and diabetic kidney disease. Thank you.
Very good evening, everybody. At the outset, I'll thank Professor Dr. Jayant Panda sir, my teacher, and the organizing team for giving me this opportunity, and my respected, not mine, the Odisha's respected stalwart of medicine, Professor Dr. Niranjan Tripathi sir, esteemed chairpersons, and my seniors, teachers and colleagues. So today we are discussing a very interesting subject, so everybody is interested in this subject. So diabetic kidney disease, as we all know, 800 million people worldwide suffering from CKD, and out of them 70% are ESRD due to diabetes. So diabetes is the most common cause of ESRD, and people are depending for renal replacement therapy. So this is the most common and dreaded complication of diabetes, that is diabetic kidney disease. So the prevalence we all know, it is in type 1 diabetes 25 to 40%, and in type 2 it is 4 to 40%. So what is the definition? Before going to the definition, I will tell that before 2004 there was no CKD, only CRF, and that is a dreaded term, and it is a death sentence to the patient. And in 2004 the term CKD was coined, and in 2007 the KEDOKI consensus collaborative that gave the term diabetic kidney disease. And the diabetic kidney disease definition is, it is persistent and progressive albuminuria from moderate to severe and progressive decline in eGFR below 60 ml per minute per 1.73 meter square over 3 to 6 months. And diabetic nephropathy, we should not confuse both, because one is not alternative of the other. Because diabetic nephropathy, it is a pathological or histopathological term. By definition, it is showing in the biopsy of the kidney mesangial hypercellularity, mesangial matrix expansion, endothelial dysfunction, the glomerular basement membrane thickening due to extracellular matrix deposition, podocyturia, the podocyte injury, and not the less the interstitial fibrosis and tubular atrophy leading to glomerulosclerosis. So this is the beautiful slide, though it is not visible I think to everybody, but this is the beautiful and a recent slide given by the American Society of Nephrology and National Kidney Foundation. This is the classification and giving the subgroup of patient, when to screen, when to treat immediately and refer to the nephrologist, when to treat and urgently refer to the nephrologist, and when do not treat immediately then refer to the nephrologist. So accordingly, there are 4 categories of patient. The green category is the only screen. They are the low risk. The yellow zone is treat. You should treat, the physician can treat the yellow zone. The orange zone is treat and do a referral. And the stage 4, the 4 subgroup again subdivided into 2 groups, the pink zone and a brick red zone. So this pink zone you treat and suggest to go to the nephrologist for renal replacement therapy and AV fistula. But in brick red zone, there is kidney failure and severe albuminuria. You should not treat the patient, immediately refer to the nephrologist. So, for early detection of the diabetes, kidney disease, this is the dreaded disease, what we should do? If the diabetic patient on type 1 diabetes, we should screen annually or every yearly if the patient is more than 5 years of diagnosis. And if the type 2 diabetes, we should do immediately after diagnosis every yearly. What we should screen? We should screen the spot urine ACR or albumin creatine ratio and the estimation of EGFR. If these two are high, that means more than EGFR is less than 60 ml per minute, persistently more than 3 to 6 months you are observing, or the urine ACR is more than 30 milligram per gram, it is the patient who is diagnosed as the diabetic kidney disease. So this is the diagnosis. Once diagnosed, then we should treat immediately. So annual screening, all individual I told. So early morning spot urine for urine ACR is the most important. 2 to 3 spot urine sample, 3 to 6 months should be there for persistent rise in the albuminuria, and 24-hour urine collection is the gold standard. Though it is a very busy slide, but this will give you many things. If the patient is coming diabetic with raised urine ACR and there is EGFR is below 60, then we should whether it is persistent or not. If it is persistent and type 1 diabetes but less than 5 years, then we should go for a kidney biopsy to rule out non-diabetic kidney disease. And if the patient is type 2 diabetes, retinopathy is there, then it is a diabetic kidney disease. And if the patient is having no retinopathy, type 1, then we will again go for the kidney biopsy. So EGFR using creatine based is the CKD-EPI equation we all are using. Renal biopsy is the indication when there is active sediment is there. That means the RBC cast is there and acanthocytes are there. There is nephrotic range proteinuria. There is absence of retinopathy and very short duration of diabetes or diabetes associated with other clinical diseases like lupus nephritis you are suspecting, or you are suspecting amyloidosis. So there are few biomarkers which will give the early detection of a diabetes. We all know in JASN. So these biomarkers are glomerular, tubular, oxidative biomarkers or inflammatory biomarkers. There are few emerging biomarkers. These are the novel biomarkers, the microparticles, the microRNA, the urinary exosomes. So these are in the phase 2 or in the research level. So coming to the intervention, the KDIGO 2022 guideline gives the comprehensive treatment of the diabetes. Number 1 is lifestyle modification. How we will do that? The high fiber diet, the moderate physical exercise, it is 150 minutes per week. We all know cessation of the smoking, reduction of the weight if it is more than 25 BMI, and we should go for pharmacotherapy very well. We all know SGLT2 inhibitor, and it should be given if the EGFR is more than 20. And as soon as the patient is going for the renal transplantation, we should discontinue. Previously it is thought that in dialysis we should discontinue, but now KDIGO tells that even if the patient is on dialysis, we should continue SGLT2 inhibitor, not for the renal protection, for the cardiovascular protection. And what about metformin? Metformin should be given to the patient if the EGFR is more than 30. And for blood pressure and proteinuria in diabetic patient, we all know the age-old therapy, the ACE inhibitor and ARB. And for atherosclerotic cardiovascular disease, we know we will give the atorvastatin as ezetimibe. But if the glycemia is not achieved, the next line is the GLP-1 receptor agonist. And if the patient blood pressure is not controlled, then we can go for the CCB or resistant hypertension, we can go for the spironolactone. But one thing is that if the patient is proteinuric, then we should go for the non-steroidal mineral category receptor antagonist. So this is the beautiful pyramid given by the KDIGO 2022. This is the comprehensive DKD management. The base of the pyramid shows, I already explained the lifestyle modification. The second line I told the metformin is the number 1 drug, number 2 is the SGLT2 inhibitor, RAS blocker and statin. So those are the targeted directed therapy, the non-steroidal mineral category receptor antagonist and the SGLT2, GLP-1 receptor agonist and antiplatelet, along with glycemic control, lipid management and target blood pressure control. So that this I have already told the comprehensive management KDIGO 22. So coming to the glycemia per se, how we will approach the patient diabetic kidney disease to control the glycemia. The number 1 is the physical activity, the lifestyle holistic approach. I always telling you the physical activity, high fiber diet, smoking cessation, weight reduction, this is the mainstay. And second line is the metformin and SGLT2 inhibitor. So metformin should be 50% dose reduced if eGFR is below 45, below 30 eGFR, metformin should not be given for lactic acidosis, and in dialysis it should be immediately discontinued. And SGLT2 inhibitor I already explained, and next line is GLP-1 and others. So the blood pressure control, we all know a diabetic patient with hypertension and whether there is proteinuria, non-proteinuria, but we have to give the first line therapy ACE inhibitor and ARB. But there is one thing I will tell, that on starting the ACE inhibitor ARB, within 2 to 4 weeks we should see whether normocalemia or less than 30% reduction of the creatinine, then we will escalate the dose of ACE inhibitor ARB to the maximum tolerated dose. If there is hyperkalemia, then we should see what is the drug, associated drug that is causing the hyperkalemia. We should hold the high potassium diets, and we should give the diuretics, sodium bicarbonate and potassium binder to reduce the hyperkalemia. If there is more than 30% reduction of eGFR or rise in creatinine, then we should hold the ACE inhibitor for some time, but we should not stop. And we should see what is the cause of AKI, whether there is volume reduction is there is septicemia, or there is renal artery stenosis. We will evaluate and then we will continue. So the blood pressure target is given by the ADA and KDIGO is, if the diabetic kidney disease, the BP target is less than 130/80 if the patient is proteinuric. If the patient is not proteinuric, then the target is 140/90. And always the ACE inhibitor is the number 1 drug of choice. So this is the mechanism of action. We all know where the SGLT2 inhibitor acts. It is the segment 3 of the proximal convoluted tubule, and it is the SYM port which is blocked by the SGLT2 inhibitor. So these are the landmark trial. We all know the Credence, DAPA-CKD and the EMPA kidney. The EMPA kidney is terminated very early because of a very nice, good, positive result. So we all know about this. I will tell only few lines about the SGLT2 inhibitor. Who are the eligible patients? The eGFR should be more than 20 and ACR should be more than 200 microgram, and the patient should have a heart failure. And what are the contraindications? If there is recurrent genital infection or fungal infection is there, diabetic ketoacidosis history is there, diabetic foot ulcer is there, or patient is on immunosuppression, rightly as I am telling transplantation, it is not right. And what education we should give to the patient? We should educate the patient about the sick day protocol, the preoperative protocol, if the patient is developing the diabetic foot ulcer, and also the weekend protocol. It should be given 2 days halt, Monday to Friday, 2 days halt for the SGLT2 inhibitor. And we should educate about the side effects and immediate to come to the physician or the nephrologist or cardiologist. So what about aldosterone? Aldosterone is a age-old molecule. This is the timeline of spironolactone, and in 2002 it is eplenon, and 2020-21 it is Fiedler who gave the phenerenon. It is the novel drug now in the proteinuric diabetic kidney disease. And Fiedler DKD and Figaro DKD, they gave the positive result in diabetic kidney disease with uncontrolled proteinuria, even if SGLT2 inhibitor and ACE inhibitor. So this is showing how they are effective in comparison to placebo. So this is the mechanism of action, how it inhibits the mineral corticoid receptors. So non-steroidal mineral corticoid receptor antagonist, we all know they mitigate the proteinuria and they have a cardioprotective effect also. So one thing I will tell that if potassium is less than 4.8, we will start 10 milligram if EGFR is less than 60. If EGFR is more than 60, we will start 20 milligram. We will assess the patient after 1 month and every 4 months. If it is 4.9 to 5.5, we will continue the same dose. If it is more than 5.5, then we will hold the phenerenon till the potassium is less than 5 millimole per liter to restart. So these are a few emerging treatments. They are in the few are in the phase 2-3 trial, and few are now in the treatment. ACE inhibitor is age-old. Mineral corticoid receptor antagonist we are using now. Endothelin receptor has come to the market. And this is my conclusion. In spite of everything, the diabetic kidney disease is a progressive disease. It is progressing. So the reversal is $1 million question. So till we are trying our best. So thank you.
Thank you, madam, for such a wonderful presentation. Thank you. From audience, any question?
My question is biopsy is mandatory? Number one. Second is, patient is having diabetic kidney disease and established case of CKD with diabetes. How to differentiate clinically in that situation?
Sir, I'll answer to your first question. The diabetes patient coming to you is divided into two. One is diabetic kidney disease, another is non-diabetic kidney disease. Again, diabetic kidney disease is divided into two. That is proteinuric diabetic kidney disease, non-proteinuric diabetic kidney disease. If there are there are stringent guidelines for doing kidney biopsy in diabetic kidney disease. Number one is patient is having nephrotic range proteinuria with renal failure. Number two, the nephrotic range proteinuria with renal failure without retinopathy. Number three is nephrotic range proteinuria and normal kidney function or EGFR, and there is rapid progressive renal failure is there, uncontrolled hypertension, not responding to the treatment, and another is there is associated systemic diseases like lupus, as I told, the amyloidosis is there, or there is urinary sediments.
Okay, so biopsy is not mandatory.
Not
so
mandatory.
More or less a clinical
yes.
approach.
No.
Okay.
So if it is, if a patient is coming to us with diabetic kidney disease,
what happened now? If you are planning for like a patient is having diabetic kidney disease, end-stage renal failure, and they are planning for transplantations, in that case probably biopsy is not required.
not required. Sir. If the kidney is contracted, so
Yes.
we should not go for the kidney biopsy.
Yes, another point I just wanted to highlight. In diabetic kidney disease, probably the kidney size remain normal or little bit bigger.
Yes.
But as contrary, the CKD, the kidney size is smaller.
But
so,
end stage, due to uremia, if you will go for the kidney biopsy, there will be very much bleeding and an nephrectomy may required. So we are
that is
not
one,
using that. Yes.
Okay. Thank you. Any question from the floor? Yeah, please.
Yes, sir.
Good evening, ma'am. Very thankful to you for your nice lecture. Ma'am, what sir told regarding the kidney biopsy, just it's not my question, it's an opinion from your side. that if the patient is having diabetic and proteinuric and not having a retinopathy or the neuropathy, other things are being excluded, would you like to go for the biopsy of the kidney?
If it is a type 1 diabetes and more than 5 years, there is no retinopathy and it is proteinuric, then I will go for the less than 5 years, no retinopathy, proteinuria, will go for the kidney biopsy to rule out non-diabetic kidney disease. Yes. And in case of type 2 diabetes mellitus, it may happen because only 70% cases of type 2 diabetes, that is congruence between the retinopathy and nephropathy. So in that case, may not be retinopathy, but we should go for the kidney biopsy to give a tissue diagnosis if it is in the research or in the academic interest. But if you are happy with the clinical diagnosis, then it is good and well, why to go for intervention?
Thank you, ma'am. And second question is that, second opinion from your side is that, regarding the using of the MRS, which is having the very promising effect on the delaying of the process of the CKD, from early proteinuria or early microalbuminuria, should we start that things?
Yes, if you are thinking of SGLT2 inhibitor, then you should have a proteinuria more than 200. But you should start the pinirenan along with SGLT2 inhibitor at least at proteinuria 30 milligram per gram or 30 milligram per day in timed collection. Because it is very low proteinuria, you have to start the pinirenan. It is promising result. But one thing is that you have to start first the SE inhibitor, then second is SGLT2 inhibitor, third is the pinirenan. Not that you will omit those two and this one is the first. It is the sequence you have to give that.
Thank you, ma'am. SGLT2 inhibitor less than 20, what you told not to start that things. But less than 20, the glycemic effect is not there.
Not there.
But the proteinuria effect is there or not, ma'am?
Yeah, we are not interested in proteinuric effect once the patient is end stage. We are much more interested in cardiovascular disease because ESRD 90 to 99% of cases of death due to cardiovascular disease only. And in CKD there is accelerated atherosclerosis. To prevent that, even in now, KDIGO tells that even the patient in dialysis also, we should continue the SGLT2 inhibitor.
Thank you, ma'am. Thank you, ma'am. Regarding this one question, most of the time we are discussing about type 1, type 2 diabetes.
Yes, sir.
But not on regarding the secondary problem, leave it the pregnancy, GDM. Apart from that, is quite chunk of patients are due to secondary diabetes. Is there a specific guideline for secondary diabetes with nephropathy? Second thing, most of the time we are using in diabetic nephropathy SGLT2 inhibitor causes hyperkalemia. Second thing, ARB causes hyperkalemia, and your mineral corticoids, they also cause hyperglycemia. Like even also your phenylalanine or eplerenone, they cause hyperkalemia. If you are using three, how to manage hyperkalemic state? That is most important feature for our patients.
Yes, sir. So number one, I'll answer your number one question, sir. The gestational diabetes mellitus, it is seen that secondary. Okay, sir. Okay, sir. Secondary diabetes, there is the guideline regarding diabetic kidney disease, sir? Yes, sir. If any patient developing diabetic kidney disease, the ACE inhibitor is number one. But in type 1 diabetes, we have to be very cautious about SGLT2 inhibitor because diabetic ketoacidosis is a threat. Because there is a chance of non-diabetic ketoacidosis if we are using the SGLT2 inhibitor. So some caution is there in type 1 diabetes. And what about the NODAT, the new onset diabetes after transplant? Also in that case, only 1 to 2 study in world scenario has been done, and among 1 to 2 study, very few 5 to 6% they have taken. They have given positive result, but still then worldwide it is not accepted in the secondary. And the second question of yours is hyperkalemia. hyperkalemia, first we will give the SGLT2 inhibitor. We will see whether hyperkalemia is there or not. If the patient is well tolerated, hyperkalemia is well tolerated and the patient is tolerating the ACE inhibitor in maximum tolerated dose, then we will go for the SGLT2 inhibitor. If the patient is tolerating SGLT2 inhibitor, then again we will go for the finerenone. And if we are giving the finerenone, we should be very much cautious and we always observe the patient within 4 weeks about the hyperkalemia. As soon as the patient develops hyperkalemia more than 5.5, we should immediately stop the finerenone and we will observe till the potassium level comes below 5 and we will restart. And if in the meantime the patient is developing hyperkalemia, we will look for the other drugs. We will immediately remove the finerenone, not ACE inhibitor, because which one is the most important, we will keep that. And another thing is we should avoid the hyperkalemic drugs, the drugs causing hyperkalemia, and we will treat the patient the potassium binders also.
Madam, good question. Up to what eGFR decline we can continue finerenone?
eGFR below 30, we will up to 30 will give, but below 30, as soon as the patient is entering into stage 4 of CKD, then there is more chance of electrolyte imbalance in the form of hyperkalemia. But up to ESRD we can go, but if the patient is very much compliance to the serum potassium level, we have to see the serum potassium level very frequently. If you are assessing that, then it's okay, up to eGFR 15. But below 15, it is not recommended.
Madam, one question. You are told persistent microalbuminuria.
Yes. The patient should be at least 2 to 3 readings in 3 to 6 months. That means every 6 to 8 weeks you have to follow up the patient once with the urine ACR.
Can you take the discussion?
Yes.
So already delayed actually, no? You can already delayed. We can have a next discussion. Okay, thank you, Dr. Aruna. Please be seated.
Thank you, sir.
Please be seated. Let's welcome next speaker, Dr. Sanjay Das. He is from Talcher. He is having Sanjay Das Wellness Center, Fellow of Indian College of Physicians, Fellow of American College of Physicians, Vice Chairman RSSDI Odisha from the 2021 to 24, Joint Secretary API Odisha, Founder Member of RSSDI Odisha. He is being invited for many areas for as a speaker and contributed chapter. His topic of presentation will be tackling barriers to insulin initiation in type 2 diabetes mellitus. Dr. Sanjay sir, please.
So, good evening everyone. Thank you, chairpersons. I thank Jayant, my dear good friend, for inviting me to this program. I have been part of RSSDI. Odisha chapter since 2000, since its inception 12 years back. So my topic will be tackling barriers to insulin initiation in type 2 diabetes. I have no conflict of interest. The agenda will be introduction, barriers, solution and conclusion. As you all know, IDF 2021, the latest one, has enumerated the state of health of diabetes in this world, and you all know India is the second largest country with having the second highest number of diabetic patients. China is number 1. But if we see 2023 data of ICMR India, we are having more than 10 crores diabetics in our country and more than 13 crores are pre-diabetic. So we have got a huge challenge, and all this in a population that has relatively earlier type 2 diabetes, highest insulin resistance and greater insulin secretory defect. So we have got a problem in our hand. So why and when is insulin necessary for people with type 2 diabetes? by the time diabetes, type 2 diabetes is diagnosed, it's already 10 years late. Insulin secretory defect, beta cell secretory defect has already started 10 years before that. So we are already dealing with a patient whose pancreatic beta cell is already 50% damaged. So what we should give, whether we should start with oral hypoglycemic or non-insulin therapy or insulin therapy. What are the protocols, what it says? We all know insulin is the most powerful anti-hyperglycemic drug which we have presently, and it can reduce A1C by as much as 1.91%. So insulin is the most powerful anti-hyperglycemic drug which we have. And you all know, if we are having good glycemic control, then we are having lots of microvascular and macrovascular complications we are dealing, or we are preventing microvascular and some macrovascular complications. This is quite elucidated in UK PDS study. So when to start? This is the slide where actually the confusion starts. The recent ADA guidelines as well as the AACE guidelines say that insulin should be started when A1C is 10%, or the patient is symptomatic, or he is uncontrolled with 3 OHs. So this is the problem why insulin initiation by healthcare, we all HCPs, we are finding it difficult to actually start insulin. We all know earlier and appropriate intervention may improve patients' chances of reaching goal, but what we are doing, we are making it so cumbersome that it's a step ladder pattern, and we are giving diet first, then OAD, then increasing the OAD, then finally we are going to basal insulin and then prandial insulin or basal bolus insulin. But if we start with earlier and more aggressive interventional approach should be there, then only we can prevent micro and vascular complications and macrovascular complications. So the need of the hour is to reach A1C goal as quickly and as possible, and that is only possible with insulin. What we are doing actually, we are using multiple OADs, which is driven by convenience, acceptance by patients, and limited consultation time. We are not spending enough time with our patients. Successive OADs, as you all know, will reduce very meagerly the A1C, and if we start, substantial benefit will be there if we start in insulin. You all can see in this one, if you are giving 2 OADs, then A1C will be reduced only by 0.5%, and if you are giving 3, then A1C will not in fact reduce, and if you are starting with insulin, then A1C will be reduced substantially by more than 1.3%. So insulin should be started timely or as early as possible. In spite of this, what we are seeing in our country is, it's more than 20 years of diabetes, only then it is 50% are on insulin and add-on drugs, and 50% are still on OADs, 2, 3 or more than that. Burden of uncontrolled diabetes in India, the studies have shown that target A1C, which is 7%, only 19% to 23%. In different studies we are achieving A1C 7%, only 19 to 23%. In our country, only 6 million people are actually on insulin. 5 out of 10 people with uncontrolled diabetes who required insulin, only 5 are actually being given. So this is the current insulin initiation practices, whatever I told in the previous slides. So now I am introducing a topic, clinical inertia in diabetes. The term clinical inertia classically defined as failure of healthcare providers to initiate or intensify therapy when indicated, and it has got 5 steps. One is primordial prevention, then primary prevention, then secondary prevention, then tertiary prevention, and finally there will be organ damage. So primordial prevention, when the person is actually not having pre-diabetes or diabetes, and it will be elucidated in the next slide. At population level, not taking steps to improve physical activity or encouraging healthy eating and reducing obesity to the final stage in the tertiary level when actually the patient is having diabetes which is uncontrolled and we are not identifying the complications, microvascular and macrovascular complications. So this leads to end stage complications, that is renal failure, amputation, heart attack and stroke. So this is how clinical inertia is boomeranging on us and our patients are suffering for that. So there are three types of clinical inertia. One is the initiation inertia, delayed initiation of insulin, then titration inertia, lack of timely dose, then delayed insulin regimen intensification, that is intensification inertia. So now I will go to barriers. So what are the barriers? The barriers are physician related or patient related. In the physician related, we all know hypoglycemia is the most dreaded complication of type 2 diabetes or type 1 diabetes, and 75% of we all doctors, we say that risk of hypoglycemia was a barrier to insulin therapy. Weight gain is also very common, so we are apprehensive, our patients are apprehensive, and then poor quality of life. Our patients think that insulin, they will be having poor quality of life. So the lack of experience, many of our HCPs actually they do not know the types of insulin, the recent devices which have come and what are the complications and how to use those insulins. So there are actually deficient. Our system is such that many of our doctors who are actually caregivers in the primary level, they do not know when to start insulin and how to start insulin and what are the doses and what are the devices. So this is one very important factor for barriers, for physician barriers. Then concerning, this is very important in our country, actually this is seen in several countries, in Western countries. If you are going to substitute the drug to insulin, the doctor will, the patient will substitute you. He will go to some other doctor because you are informing that now you require insulin. So instead of taking insulin, they will go to some other doctor. So complexities, suboptimal knowledge on guidelines, which I have told. The guidelines are also, nowadays the guidelines are not very comprehensive and not very easy going. Then there is differences among guideline recommendations from various organizations. Changing targets. We all know 7 is not the hallmark. Many patients should have 8, like some, if some are having some complications, or elderly populations. And in the younger age, like 17 years, 20 years, it should not be 7, the target should be less. Though all of us should know all these things, our HCPs are not knowing these things. Then newer therapies, a lot of new insulin have come in the market, which are actually doing wonder to our patients, which many of us are not knowing. So insufficient resources, you all know, we spend less than, I know many of my doctor colleagues are spending less than 1 minute to a patient because they are seeing hundreds of patients a day. So if you are giving less than 10 minutes to a patient, then how you are going to train them for the best thing possible, best treatment possible for diabetes. So what we are not lacking in our clinic, we are lacking our associates, which are the paramedical, which are diabetes educator or dietitian. We are not having trained paramedical staff. This is one very important reason for barriers for initiation of insulin. Then about the patient, this is defined, psychological insulin resistance is defined as psychological opposition towards insulin, and this is because of injection, insulin, needle phobia, then perceived lack of control. They think that no, it will not solve my problem. Then low self-efficacy, personal failure. The patients think that because of their folly, their insulin sugar is rising. Then positive gain is not expected. Concerns about adverse effects and cost concerns. So impact of PR, what happens? Finally, because of PR, there is increased risk of complications, and this results to microvascular and macrovascular complications if you are not treating the patient properly. Now the solution, what are the solutions? The solution, you have to determine, introduce, explain, educate and follow up. Determine patient barriers to insulin and address, introduce patient to insulin, explain the benefits and risks, why you are starting insulin and the regimen, educate the injection techniques, the units, dose, frequency and storage. Then you should educate about the hypos, how to prevent and what are the blood glucose goals for them. And you should follow up the patients who are on insulin recently. You should follow up every 1 to 2 weeks, so that they will be confident of starting insulin and continuing insulin. So the solution are physician education, all HCPs should be educated, CMEs should be hold like this, what we are discussing today. We should have these CMEs and workshops to identify the right patient for insulin therapy, to administer insulin safely and effectively, and empower HCPs to teach the right technique to their patients. So reduce the burden. We should have paramedical staff with us. Use of nurses, pharmacists, diabetes educators will give HCPs more time for consultation, more frequent review, increases trust. The patient will have more trust on you. It builds strong foundation for therapeutic relationship, and it helps reduce non-compliance. So innovation in therapy, as you all know, lots of devices have come which are painless, which are very painless. The needles are also now painless, very small needle, the gauge is very less, its wide is less than 4 millimeter and 32 is the size, and it causes new devices and new insulins are there which causes lesser hypoglycemia, lesser weight gain and better quality of life. Effective conversation is the key. You should ascertain how patient feels about insulin. You should explain and educate, solve the problem with the patient, develop plan together and set expectations. The patients say that taking insulin means I have failed to manage diabetes with diet and tablets. You should inform them beforehand that diabetes is a progressive disorder. It's not your failure. It is a progressive disorder, and insulin is the best and the natural management because you are lacking insulin in your body and you have to take it from outside, and they have not failed. It is not you which have failed, but the disease is progressive, and you should motivate the patient, then they should not have any guilt conscious with them. Taking insulin makes it more difficult to fulfill my responsibility. As you all know, newer devices are there, newer insulins are there. You can take basal insulin, long-acting insulin, which can work for 36 hours. And nowadays, another 2 molecules are on the pipeline, which will be once a week basal insulin, which are on the pipeline, which should come in a couple of months or 2-3 years. Newer insulin with flexible regimens are available. I am afraid of injecting myself with needle. We must teach them the injection technique. We should take the dry injection ourselves. When I was trained for diabetes in 2001, so me and Dr. Dandania, he was around here. So we had gone to Kochi through ADA and we were trained, and we were taking needles 3 to 4 times a day. We were behaving like a patient. We were trained how to take insulin and what it feels like taking insulin. So we should teach our patients the injection technique. We should show the pen size of the needle, demonstrate the injection process in our own clinic, and assure the patient that the insulin injecting process is very easy and painless. So hypoglycemia, this is the most important complications of, you all know, type 2 diabetes, dreaded complication which we all HCPs suffer because of these, because our patients think we do not know what has happened to them, and this is very important. Hypoglycemia, my dear friend Dr. Arvind had told in the in the last topic, it was the hypoglycemia. So what we should do? We should educate and empower patients and caregivers. It's crucial to emphasize patient education regarding hypos, and patients more than 65 years undergoing insulin treatment have a higher risk, and the rule of 15/15, which is we should give 15 grams of carbohydrate and we should check blood sugar after 15 minutes, and please remember that glucometer should be available with the patient all the time. Insulin causes weight gain. Newer insulins are there like Detamir, which doesn't cause the minimum weight gain is there with Detamir. So nowadays a lot of insulins are there which doesn't cause any such problems. So taking insulin means life, which I have already told. Taking insulin means I must give up activities. I have already explained that this is not the thing. Newer insulins and newer devices are there. So overcoming stigmas, diabetes therapy by ear. We should listen to what our patients are telling. I'll take another 2 slides. We should listen to what our patients are telling. We should understand the history. We should listen, and therapeutic patient education is very important. So lack of adherence, this is my last slide, second last slide. So now initiation has occurred, and then whether there is adherence or not, whether the patient will continue taking insulin is not, that is also a challenge. The non-adherence is estimated to be around 50% of patients. The possible factors are forgetfulness, lack of knowledge, fear of potential side effect, lack of confidence in the treatment, and economic consideration. So now use of long-acting insulins are there. 2 once weekly basal insulin are under trial. Icodec insulin, which has just failed in the FDA, US FDA has actually told them to go back to the trial again, and Lilly has started BIF basal insulin in the trial. Then dose recall system, like what we do in the DOTS, those recall systems should be there, and diabetes education program like we all do with amongst the HCPs. We should have our diabetes educator to train our patients and their family members. So conclusion, friends, in conclusion, I must tell that it is time to bridge insulin inertia. The barriers to insulinization is physician-related factors like fear of hypoglycemia, weight gain, patient loss, which is very important. Patient loss is very important. Patient-related factors like psychological resistance, injection anxiety, and lack of control. Strategies to overcome barriers are the physician education and training, reduce burden with healthcare team involvement, innovation with newer insulins, and address psychological insulin resistance. Then effective patient conversation, collaborative approach to insulin initiation, address fears, myths, and misconceptions, alleviate concerns about hypoglycemia, weight gain, and flexibility, and finally, combat insulin inertia for better diabetes management. Education, collaboration, and patient-centric approach are very crucial, my dear friends. Thank you for patient hearing.
Thank you, sir. So, as for the request from the organized team is already delayed, we can allow one question from the floor if possible. So, no question. Yeah, please.
In all the talks almost we heard, lifestyle modification is a suggested primary prevention, primordial prevention, whatever. And but we did not hear any speaker qualifying or quantifying the exercise protocol or the regimen, or even if it is person specific or not. So
actually that is not my topic, but yes, we are having exercise protocols are there. Our Indian team also has the exercise protocol. The US and Western countries say 25 minutes of brisk walking, but our countrymen say it is more than 30 minutes or 60 minutes, for more than 45 minutes brisk walking. This is what Indians' recommendation is there, 45 minutes of brisk walking. Not only the brisk walking, for your muscle toning is also very important, especially for a person who is more than 30 years or 35 years, that is also very important. So exercise is very important. Any type of exercise which is moderate exercise, if the person is actually able to do it, then brisk walking and swimming, all these, horse riding at younger age group, all these are possible, and it should be not 25 minutes, it should be 45 minutes or more per day. This is about exercise.
Thank you, sir. I can go to the next session.
Thank you.
I'll request all the chairpersons and the speakers to come up here for the felicitation. Please. And we'll get ready for the next session. We have got 2 more sessions left, so I'll be prudent, guys. Request the speakers to be prudent on time.
आपका नाम क्या है?
Hello.
दिखता आस-पास से ये है
Thank you, sir.
ये नहीं चाहिए, मुझे नॉर्मल वाला चाहिए। ये करके ना स्पीकर होना चाहिए। प्रेजेंटर व्यू हटा दो, हाइट 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 हाइट। हाँ ये चाहिए। ठीक है। तो बाद में करना इसको ऐसे करोगे, ऐसे करोगे, आ जाएगा। ये बंद है, ठीक है। 8-10 ले लेना। हाँ
सर, कौन तो सर? Thank you, Professor Jayant and the esteemed chairpersons. For the next session, I will request the chairpersons to come up here. Dr. B. Jagdish. Dr. B. Jagdish. Dr. Dinabandhu Sahu. And Dr. Devashish Das. Please.
I'll introduce first. Short introduction. Yes. Only one question. Yeah. Good evening, all. So diabetes and obesity, they go hand in hand, and it's on the rise. And even obesity is being considered as the mother root cause of all the metabolic disorders, including diabetes. To talk on this topic, I am feeling privileged to call upon the dais the veteran expert, Dr. Vinod Mittal, who is now heading the Center for Diabetes and Metabolic Disorders in Delhi Heart and Lung Institute. With his vast career of 35 years, he has received many honors and awards, national and international orations and RSSDI awards. And also, he is the principal investigator in several research projects and trials. And also, he has got hundreds of publications in top peer-reviewed journals and chapters in various books. I invite sir. Thanks.
Good evening, everyone. It's my proud privilege to be here to share my knowledge. It's not coming. Yeah, so it's my proud privilege to be here to share my knowledge on alpha cell, a novel therapeutic target in diabetes management. So whenever we talk of, it's little out of the box, you might feel, because when we talk of diabetes or obesity, we talk of beta cells. So where come these alpha cells come into play? And alpha cells produce glucagon. So we always take alpha cells as, as the convict. They are dangerous, but it is not true. They are friend and they are the guardians of beta cells. Okay, so let's see how this happens. There's no conflict of interest. It's purely a scientific talk. So background is basically in pancreas. There's alpha, beta, delta. They all are placed very close. This is just because they have a paracrine inhibitory effect on each other. Like, beta cells will not allow alpha cells to produce more glucagon, and similarly, alpha cells also will produce glucagon if there is a hypoglycemia. Alpha cell is a complicated cell, not like beta cell. So how the studies are done now is alpha cells are extracted from human and are transplanted in the anterior chamber of rodents, and then the studies are done. That's how we are studying alpha cells. So basically there is a paracrine interaction going on between alpha and through all these transcriptors, even GABA. And multiple, like alpha cells is in the center, so delta cell produce somatostatin, which again inhibit alpha cell, beta cell produce, insulin, and through GABA also inhibit alpha cell. So in normal circumstances, there's no hyperglucogonemia. But when there's a diabetes, there's a hyperglucogonemia. Why? So glucagon, in fact, glucagon was invented next year, the very next year of insulin, 1923. Insulin was 1922. So last year was centenary year for glucagon, and we are not aware of this because this was, a hidden, molecule. So this first time in 1973, Roger Unger, he came with a theory that, there's a bihormonal theory. We used to think only, insulin deficiency. But we came to know recently in last 1 or 2 decades that there's a hyperglucogonemia also. And we should address both the things to control diabetes. So this is how the studies are done, and the cells are transplanted, implanted in the anterior chamber of rodents, and then the studies are done. Now see this is very interesting. See the stem or progenitor cell, from this alpha cell comes first and then the beta cell, okay, as a developmental process. So first is alpha cell. So alpha cells are in a way the guardians, and whenever there is a problem with beta cells, there is more production of alpha cells and there is a kind of conversion to beta cell. This is what is happening in normal circumstances. So alpha cells are trying to protect the deficiency of beta cell in normal circumstances. Now, whenever there is a stress on beta cells, that is what is inflammation. Whenever we say hyperglycemia, the first thing is an inflammatory process, and this inflammatory process leads to lipotoxicity first, followed by glucotoxicity. So first is a lipotoxicity. So whenever there is a stress on beta cells, alpha cells come into play. They are more resistant to this stress. So beta cells become dysfunctional or they die, but alpha cells are more resistant because they have a molecule which I will show you. They have more of this BCL-XL, which make alpha cells resistant to stress. So whenever there's an inflammation, there's a death of beta cell or they become dysfunctional, but alpha cells proliferate. And that is why there's a hyperglucogonemia. So there's an insulin deficiency. To compensate for that, there is a hyperinsulinemia, relative insulin deficiency, and to compensate for this deficiency, there is a hyperglucogonemia. And that's how, this thing goes on. So overall, now things are there that new therapeutic strategies are there into play, that alpha cells to beta cell reprogramming. Now beta cell deficiency, if it is there, there's a restoration of beta cell through intraductal infusion of these genetic material. Like this is the future. What I'm going to tell you today is in times to come, how to get beta cells back. What we're doing now is we are trying to stimulate beta cells or trying some other methods to control glycemia. But can we get these beta cells back? Now, other important point is that dynamic changes. We always say that at the time of diagnosis of diabetes, there is, 70%, 60%, different figures are there, beta cells are already dead, 6% every year. Now you tell me one thing, when patient is having diabetes for 20 years, even then sulfonylureas are effective in small dose. If you stop sulfonylurea, you have to increase the dose of other molecules. So that means beta cells remain. What I want to say that some of the beta cells die, the other beta cells become dysfunctional. Like we say HDL is dysfunctional. So HDL may be normal, but it is dysfunctional. So the thing is, the died beta cells may not come back, but the dysfunctional can be, they come back. So that means from beta cells to dysfunctional means de-differentiation of beta cells, and these de-differentiated beta cells can be re-differentiated back to beta cells. And that is what is there when there is a weight loss. Studies have shown when there is a weight loss, even after diabetes, say 5 years of diabetes, a lot of things are going on reversal. There's nothing reversal, it's remission. So even after 5 or 6 years of diabetes, there's a weight loss. There's some amount of remission, even after bariatric surgery. Why? Because when there's a decrease in the energy intake, the fat triglycerides which gets into pancreas and in the liver comes back to the blood. It becomes normal. That's what happens. So same is here. There is a dysfunctional beta cells also become functional. One is pioglitazone. It can make de-differentiated beta cells to re-differentiate into normal functioning beta cells. So this is one thing which we have to work on. So basically diet, pioglitazone and certain molecules are being now tested. Can we, how we can change these dysfunctional beta cells to normal functioning beta cells. So overall, there are a number of things possible now in coming times. One is de-differentiation, and then there's a re-differentiation, I've already told, and then there's a trans-differentiation also, means alpha and delta cells can be trans-differentiated to beta cells. This is what is the future. So overall, if we see, so glucagon, it increases glucose. That is only one small effect. But what it does more than that is it suppresses appetite and it increases energy expenditure. Okay? So glucagon receptor agonist can be used to reduce weight. And that is what is now coming up, triple agonist. Retatrutide, which was, last year it was discussed in ADA. It is a triple agonist. GLP-1, GIP plus glucagon receptor agonist. Try to understand. We're giving an agonist which is going to act on glucagon. We might think it will increase glucose, but no, we're giving it to reduce weight. Are you getting me? So now things are going that even glucagon receptor agonist will reduce weight. And that is what is the theory. So decreased appetite and increased energy expenditure. That's what we want. So overall, there can be two kinds of molecules. One is glucagon antagonist, which are in infancy state, but agonist, yes, we have already started using, and we have dual agonist, not available in India, but yes, tirzepatide, you must be knowing, Monjaro, it's there in US. Maybe in a year or two it would be in India, injectable. Then glucagon receptor agonist with GIP, survodutide. So these are the molecule and triple agonist I just mentioned, retatrutide. These are the future. Take my words. The last decade was SGLT2 inhibitor. Nothing much is left now. This present and the future, next 1 or 2 decades, will be GLP-1. Take my words. Everything will be GLP-1 because they have shown so many effects, even renoprotective effects. Flow trial has recently shown with semaglutide that there is a regression or less progression of DKD2 and stage renal disease. So antagonists, they are very, very in infancy state. Skyrin is the one which might come up, but that is to reduce. So glucagon antagonist to decrease blood glucose, glucagon agonist to decrease weight. Two different parameters. So these are all, and glucagon antagonists have shown effective in heart failure. So we have now 4 pillars of heart failure. Then maybe some people say vericiguat may be the 5th pillar, and then glucagon antagonist may become the 6th pillar. See, we are in search of newer and newer molecules. Agonist, I've already told you to decrease, and we already have these molecules are already there. And I will show you. The next slide is a very, very important and very interesting slide. So when obesity management comes, now you must be knowing that ADA EASD 2024 guidelines, there are 4 things we have to manage for diabetes. A1C is only one. Obesity management. We never talk. We fail in controlling glucose, what to talk of weight. Do we ever emphasize things to decrease weight besides lifestyle? No. We just say, control your diet, do this thing. So we have to have 4 things. A1C, weight management, cardiovascular risk reduction, and renoprotective. So agent which has all these 4 should be used. Simple. Not only ANC, A1C. Okay? So now see, when weight goes up, morbid obesity, we just think of bariatric surgery. Generally, that is the gold standard. Anyone who is failing will, you go and get bariatric surgery done. You think it is simple? It is, Roux-en-Y bypass, lifelong, a patient has to be on supplementation because a part of intestine has gone. So vitamins and minerals, how will they be absorbed? So patient has to be on supplementation, and lifestyle modification still to be continued. It's not that you tell, and even Roux bypass surgery also fails. It is not 100%. Take my words. And maximum weight loss is 30% in this. Okay. Now let's see this. Let's see what to talk of other molecules. And like endoscopic balloon, what we call balloon, and we sleeve gastrectomy, only 15%. This ballooning and sleeve, only 15%. So 15% we can get with this, say, even single agent, survodutide, cagrisema, and semaglutide also has shown 17.8%. Tirzepatide has shown 22% reduction in weight. Retatrutide has shown 24%, nearly 25%. So, can we say that we have reached, or we would be reaching a time that we have a bariatric surgery equal to medical bariatrics? In some people, nothing is 100%, like bariatric surgery is not 100% people, even medical bariatric is not 100% people. So there would be some category of people who may not be fit for bariatric surgery, who may not accept, because it is not easy, and the cost is also a big factor. So in times to come, again, take my words, it will be, GLP-1, but yes, we have to use with inappropriate, because SGLT2 inhibitor also, but then side effects, because if you use any molecule inappropriately, there would be adverse effects. So retatrutide, I told you 25% reduction. So dual, triple, and now triple agonist. So basically, GLP-1 will reduce glucose plus GIP. GIP will reduce even weight, and then glucagon receptor agonist triple will reduce weight further. And weight is an important part and parcel of diabetes management. Okay. So this is only to show that recently there was a lot of hue and cry, and this Ozempic is not available. So what I'm saying is, use rationally. Rational use is important. People are misusing these molecules. So that is also, oral SAMA is out of the market. Every obese patient should be given. No, it is. As of today, it is only in diabetic patients, not in non-diabetic patients. So current status is that, alpha cells are important, equally important as beta cells. In normal circumstances, normal physiological conditions, they try to protect beta cells. So a time is there when they are trying to protect, and then when they fail, there's a proliferation of alpha cells. Obviously, you become more strong, then hyperglucogonemia, hyperinsulinemia, insulin deficiency. But we have now you can see basically novel therapies targeting alpha cells, and doors has opened for new era in diabetes management. So takeaway messages are very clear that alpha cells are important as beta cells. Don't take them as convict, and they are now the target, and in times to come they would be now the prime, because we are failing. What are we doing? What to talk of prevention? We are not able to manage diabetes well. A1C reduction, see the figures. ICMR in DAB study, only 24%, 26% achieve A1C less than 7 on treatment. Okay, and so glucagon agonism and antagonism both are important. And with this, I conclude my talk, and I convey my thanks to all of you.
Thank you, sir. Thank you for enlightening us, the whole house, regarding the future molecules and future experiments relating to diabetes management. So, any questions from the house?
Only one question.
Regarding Ozempic, I heard a lot about this. As the gentleman who used this drug, he was very skeptical about the use of this drug. He told my personality as against it. I lost 24 kg, but unfortunately my personality has changed. What's your opinion regarding Ozempic?
See, if we talk of, only obesity management, weight reduction. So one thing I must tell you, now the latest is, it is not just weight reduction, it is obesity management. Means weight loss in terms of fat and preservation of muscle mass also. Because if you lose both, then you lose everything. So you have to preserve muscle mass also. No, that's one. The second is, only anti-diabetic agent which have been approved in obesity are GLP-1. So liraglutide has been approved. What?
He was not
That's what I'm saying. That's what I'm saying. So for this semaglutide, for only 3 medication, aging, so they lose weight, but they become 5 or 10 years older. They appear like that. So Ozempic phase